And I think I'd like to introduce a very important person to Sustainable Buildings Canada. Up in my top left corner, I have Bryn Neely, our Executive Director, and I think I'm going to let you go ahead and take it away.
Hi, everybody, and thanks so much, Bettina. I've been really excited about this event. I'm pretty new with Sustainable Buildings Canada, although approaching the 1-year mark in the not too distant future. This has been my first series of Better Buildings Boot Camp, and I have just heard so many positive things since joining the organization last November. And so it's really been a thrill for me to be able to see what it's all about. And um, our mission is really, this program exemplifies our mission as an organization of connecting people who have a whole wide range of interactions with the built environment, people taking various sciences, various engineering, architecture, land use planning, business. It's really been pretty incredible for me to see how many people see the powerful impact that their line of training and specialty can play a role in improving the built environment and aiming towards a net positive future that I think we all want to see unfold. So thank you so much for letting me join you and see how this virtual workshop will unfold. And I one of the things that I'm really excited about this is I've been exposed to so many past participants in the Better Buildings Boot Camp because people, from what I can tell, walk away with it feeling so invigorated and excited to keep contributing to the work. And they've gone on to collaborate with us in research, in some of the services that we deliver, in continuing the legacy of this program. And so I hope that as the August 2025 cohort, I'll be seeing many of your faces long past the end of this week and getting to watch your careers as they unfold and evolve and have such positive impact. So yeah, enjoy the week.
Thank you, Bryn. So at Sustainable Buildings Canada, we believe deeply in decolonization, and we use that word purposefully. There are many things that have happened in our built environment that have done great harm. And so we acknowledge that our offices, we don't actually have offices. So right now I'm sitting in the city of Toronto, downtown Toronto, Front and Frederick. In fact, Front was the lakefront, and we have filled it in to add more land, which is a questionable practice and has many consequences. And there are many things that we do without understanding both the impact and, of course, the damage and the harm that we have and continue to do. So I'm located in the lands that are known as Takaranto, which I love that word. Translates from the Mohawk as the place where trees stand in the water. And if you think about how our cityscape looks, especially with the islands in front of it, and contrast that to the natural place that this must have been millennia ago. We're within the traditional lands of the Anishinaabe, the Chippewa, the Wendat, and the Haudenosaunee people. And we're covered by Treaty 13, which was signed with the Mississaugas of the Credit, as well as the Williams Treaties, signed by multiple Mississaugas and Chippewa bands. We're part of the two-row wampum and dish with one spoon covenant. The dish with one spoon covenant is one of my favorite learnings that I have had. And the idea is that when we have a dish with one spoon, we take no more than we need and leaving enough for others. And so the more I'm a new Canadian, the more I have learned about the knowledge and the awareness and the strength that the peoples who have taken care of this land from time immemorial, the more I learn about it, the more logical it all is and the more amazing it is. And what we try to do at SBC is also learn from this concept of two-eyed seeing. We are in a modern world. We have modern laws. We have land ownership, which is a concept that doesn't make sense. The land is the land. It belongs to no one. It belongs to all of us. But we do live in a space uh, where the reality is there are laws, and we are part of the built environment, and the built environment can both harm and help both humans and the land. And so as we go through the week, hopefully we'll find ways of keeping that continually in our background, that yes, we're striving for modern, amazing, great buildings, but we're doing so in the context of the land and the people and the spirit and everything that has been here on this land before us and will continue way beyond the buildings that we make and inhabit. I'm going to tell you a tiny bit. Would anyone like to say a land acknowledgement of the place where you are right now? I'll leave it. We'll try every day and start. So if you have, I encourage, so land acknowledgements can be perfunctory. We try very hard not to make them so. We try very hard to encourage people to do that little bit of research about where you are and who was there before you and who's taking care of the lands. If you are an Indigenous person, we welcome you to speak to us about anything that is meaningful to you about your experience here with us, and to share, anything. So this is an open space. I hope you feel this over the course of the week. We're not going to just be hanging out and putting PowerPoints up. We're really going to hope to get some dialogue with you, and you'll be meeting your team. You'll be meeting people in breakout rooms. So we really are hoping to make this as interactive, despite the fact that we're stuck on the computer, but we really want you to feel that you are a part of this and that you are welcome. So how does this week work? We have a real building. I don't know if you've had a chance to look at the stuff that Diana has sent out. I see a couple of nods. That's awesome. So we have a real building. It's an affordable housing building in the city of Durham. So this building actually is happening. And we have the team of the city of Durham, who are here to talk to us about what it's like to suddenly have a building that they are designing for an incredibly important group of people, and all of the thinking that's going on now as they are getting into a little bit more of the details of what this building is going to be. So I won't give you any spoiler alerts on that, but we'll be hearing from the city of Durham. We'll be hearing from uh, people who will tell us all day today is going to be about how do we set goals. Just like when you're doing your studies, there's certain courses where you're going to be like, on this one, I'm going to nail it. I'm going to get that A+ if I can, and then other courses you're like, maybe this is a required one. I kind of have to do it. I'm going to put the effort in, but I'm going to measure that effort that I put into it and use it on something else. And maybe you also have a job and a family and all sorts of other factors. So buildings are the same. Buildings have a lot of conflicting priorities, including budget, including rules that surround them, etc. So think of the building kind of like a project that's happening, and a lot of people are going to have to make a lot of decisions about this building. So today is about goals. How do we set goals for buildings, for municipalities, for provinces, for countries? And those goals can sometimes be conflicting. Day 2 is all about tools. What are the tools that we use? Now, some of you are studying building science and you know all about energy modeling. Some of you have never heard of energy modeling, and that's okay. That's the reality in the built environment. When a new building happens, there will be some people who will be in charge of financing it, some people who will be in charge of designing it, etc. There'll be lots and lots of involvement, and it takes a lot of people to figure out how a really good building happens. And so Tuesday, we're going to be talking about the tools that are used commonly in high performance buildings, really good, better buildings. You're going to tell us some of the tools that you might have in your field. Because what we know is that when people get together with different skills and different knowledge and they share, all of our knowledge expands. So everyone is welcome here. It doesn't matter what you're studying or what your experience is. You're going to find a place where you're going to learn something, or you're going to share something with somebody else. Wednesday is all about humans in the built environment. We'll have a speaker speaking to us about decolonizing the built environment, accessibility, uh, uh, indoor environmental quality, diversity, equity, and inclusion. Then Thursday is when we're actually going to observe. Monday, Tuesday, Wednesday are to prepare all of us to observe what we call an integrated design workshop. So that is the core of really good buildings, is when you get lots of people together iteratively several times over the course of the design of the building and even into the operations of the building if you go IPD. And you'll be observing it and our team will be there. You'll be prepared to see it and to understand it. Friday, we'll have a couple more presentations, really exciting ones, and then we turn it to you. Your teams will be giving recommendations to the actual building team because you will know enough by Friday. Your group will have its own particular recommendation to the team. So any questions? Okay, I'll let you off this time, but I want no hands up, just unmute. I'd like everyone to practice that now. Could everyone unmute? I don't care if your camera's on or not. And I just want everyone to say, hello, good morning. Are you ready? 1, 2, 3.
Hi.
Hello,
Mute's
good
on.
morning.
Good
Good
morning.
morning. Oh, morning. Morning.
Oh, awesome. Welcome, humans, and you're very welcome. Okay, so I'm going to call on Diana and Daniel and Krishna and Oya. And I'd like you to introduce yourselves quickly.
So I'll go first. Hello, everyone. My name is Diana. You should have all received emails from me. I am the program coordinator for Better Buildings Boot Camp. If at any point in the boot camp you have any questions, comments, concerns, don't be afraid to send me an email or message me privately in the chat. Daniel, if you will.
Hi, everybody. My name's Daniel. I am so excited to be here. I'm going to be supporting you guys on the tech back end to make sure that everything is running smoothly. I'm thrilled to be seeing so many happy faces from what I've seen participating in the bootcamp. So feel free to reach out and ask any questions through the chat if you have them. Myself and some of our lovely volunteers will be, I think, helping you out. So you're in for a treat over the next week, and I'm thrilled that you're all here.
Krishna?
Hi guys, my name is Krishna. I have a background in building science, and I find this bootcamp to be very intriguing to be kind of also incorporated with the stuff that I have studied before. So if you have any questions or anything, please reach out to me. And I know this bootcamp, I was here for the in-person one that happened last month, and it was very engaging and very exciting. I think you guys are in for a treat with this Better Buildings Bootcamp. So if you have any questions, just like what Daniel said, feel free to reach out to me as well.
And Oya.
Good morning, everyone. My name is Oya Kilome. My background area is in sustainable energy, and I just finished the last in-person bootcamp. So I thought of, oh, this is very interesting. Guess what? There was a lot to learn in this process, and so I thought, oh, I need to come back. But the way to come back and volunteer for this program now. So I very excited to be. I guarantee you this, everyone here, you will not regret why you're here because I love it. That's why I came back.
That's terrific. Thank you so much. Yeah, it is awkward and horrible to be on the Zoom, but we do create team, and you'll see that at the last boot camp, we had 4 alumni, all of who are working in sustainable buildings in some way, shape, or form, all who are, just out there. It's a small world. Even at my level, I'm the chair of sustainable buildings. I can tell you it's a tiny world. We bump into people all the time. So you are now part of our SBC family, and we are excited to have you all with us. And I think right now it is time for our very first break, and I've taken a whole minute into it, and I apologize. We will try to be very strict because standing here is, staring at the screen is hard. So take a break, stretch, drink some water, look out into the horizon so that your eyes refocus and do other things, and we'll see you at 9 o'clock.
Hello, everybody. Thank you for holding tight as we get ready. Hope you've had a nice short restful break. Maybe grabbed a coffee, a little bit of water. I have the pleasure of introducing Alex Lukachko here for you folks. If you haven't seen Alex around, he is an amazing educator, knowledgeable resource for everything around building science, climate design. He is a instructor at the University of Toronto. And he is also the director of the Climate Design Initiative. So Alex will be taking it away from here.
Great. Well, thank you, Daniel. I'm very happy to be here with the group today. This is an exciting week, I think, and an exciting day because this is the kind of kickoff for, I think, from past experience, will be an action-packed and very informative week. So I'm excited to join you right here at the beginning. And I'm going to talk to you a little bit about goal setting, just to before you dive too deeply into the project, to get a sense of like what kind of challenges we're faced with in the industry right now. And you'll see some of these things repeat in different formats throughout the week as other people come in to talk to you. And then, of course, when you do the design charrette with the professional group and the actual client, you'll probably be hearing about some of these challenges directly in that conversation. Okay, so I'm going to launch right into it, and I'm going to move pretty briskly because we've got, I think, about 50 minutes, and I could probably spend the whole day with you if I was given the chance. But I want to make sure I get through this important bit of information and maybe leave some time for some questions at the end. Okay, so let's go. Here's more or less the agenda for today. I'm going to talk about setting goals, of course, but I'm going to start by talking about the climate crisis as the context for most of our work around the built environment right now. It's a very important framework that you're familiar with, but I'm going to talk about that a little bit. I'm then going to give you some starting points for setting targets for this building. And in this program, the focus is very much focused on the performance of the project that we're looking at, but there's a number of different ways of thinking about performance. We could talk about the energy performance of the building. We could talk about durability, but we should also be talking about people and how the building performs for the people that it's going to house over the long term. And I'm going to end up by giving you some example projects that are related to that larger view of what goals are that we should be focused on. All right, so we're going to start with the climate crisis context. And I know the climate crisis is probably a pretty heavy topic to be leading off with at 9 a.m. on a Monday morning at the beginning of what is going to be a very exciting week. But I think it's important that we have a big picture conversation about this. And then I'm also going to highlight to you, for you, some key ways that we can all make a substantial difference in this. I'm going to be talking about mitigating emissions because, of course, that's something that we can do as building designers that will affect any new building and any existing building. We should be working on that. I'm also going to talk about climate change adaptation, which is something that's more of a longer term consideration about providing shelter for our society, no matter what happens in terms of climate change. And I think that in both of those areas, we can actually do quite a lot. So this starts dark, but there's an empowering message here for us as designers of the built environment. All right, so first, everyone I think is familiar with this kind of timeline. This is a barcode that shows the annual temperature in a color code going back 2,000 years or so. And you'll notice on the right-hand side of the screen, it goes from blue with a little bit of variation into white and orange to picking up into a much warmer climate. And we know that this has been happening. We also know that over the last 150 to 250 years, most of that climate change can be attributed to the actions that our society takes. If you look more precisely at this in terms of Canada, just over the last 150 years or so, you can see there's a lot of variation. And this is what we experience on a year-to-year basis. Some years are cooler, the weather is a little bit more normal, more like it was in the past. Other years are a little bit more extreme. We're in the middle of a very extreme climate in the city of Toronto and most of Canada. I'm sitting here in Nova Scotia right now, and we can smell forest fire smoke in the air that's traveling in this direction east from Quebec and New Brunswick. And of course, in Toronto, we've been having similar situations all through the summer. we're experiencing one of those higher bars. But the important thing here is that the trend is continuing. This is something that we know a lot about. So why is this happening? Like, why do we need to focus on this? Well, we know that there's a limit to how much carbon can be emitted to the atmosphere before we start exceeding these climate change targets thresholds that we think are really important to keep our climate over the long term as stable as possible. And this pie chart here is showing us what those carbon emissions are available in the atmosphere and how much of the budget we have used up basically to the present. And this is what's behind the urgency. This is why we call it a crisis, is that we have very little time and very little carbon budget left to act with. And so that's why it's pretty key for us to be focusing on right now. The Intergovernmental Panel on Climate Change has been issuing the summaries of the science around climate change every few years. The most recent one, the 6th assessment report, they've changed their language. They're not sort of dispassionately citing the science, providing information for policymakers. They're expressing more urgency here. And so this is language directly out of the summary. We're moving into an uncharted territory with climate change. We're in danger of exceeding those thresholds. If we continue on this pace, we think we're going to get into a different kind of climate. And the scientists are particularly worried about this at this moment because the further we get down this path of a warming climate, the less we know about how it's going to act and what those impacts are going to be for our society. So this is what we have to be dealing with, and I just want to underline that sense of urgency that should inform everything that we do. And the time frame here too can be related directly to our experience. This is a graphic from the same 6th assessment report. And again, it's not just a presentation of the data. You see the barcodes with the increasing temperature. You see some scenarios past 2020 for very high emissions or very low emissions. But in any one of those cases, you can see that there's expected to be significant global warming. And below this, just to reinforce this point, they put the thresholds for like time spans for human lifespans down below, right? So anyone who's been born in the past, by the time we are all in our older years, we'll be experiencing quite a different climate than we had in the past. And of course, anyone born now is going to extend into that future. And I just think that this is important, not just because scientists are telling us to pay attention and to act with urgency, but also because as designers of the built environment, we have these lifespans for people to be concerned about. These are the people that we're designing for. And remember, the buildings, the built environment as a whole that we're designing is going to last hundreds of years into the future. And so we have to be thinking now about what that's going to be. And that's one really important part of our mission. Okay, so to bring this together, maybe a way that you could use to describe this to people that you're working with, here's a chart that I think we're all kind of familiar with. This is showing into the future what the climate might be like under different scenarios. In the past, we have, so on the left-hand side in gray, we have that historical climate data, and there's always been a little bit of variation, but an upward trend, as we've been talking about. On the right-hand side, those different scenarios, the blue one on the bottom is the one that we want to be on. This is where everyone on the planet acts together to reduce emissions. This is really a team effort to get to that lower level of emissions. And that's what we think the global warming will be like in that circumstance. And then at the top, the red one is more or less, we just keep doing what we're doing in an uncoordinated fashion, not making a major impact. That's where the temperature is expected to go. And that's the one that the scientists feel is a different world, right? It's not like the world that we had in the past. And it's very difficult to design and plan for that. And of course, the impacts are supposed to be pretty severe. Okay, so that's kind of like what we're looking at here. In the short term, everything looks the same, right? Everything kind of looks like we're on the same path. It won't be for several decades until we really start seeing the differences between the effort that we're on. Another thing that's building related that I think is important to highlight is that when we're talking about designing buildings for a particular climate, we reference the building code and the climate parameters that are in the building code. Typically, they're 30 years of climate compressed into 1 year that tells you what to design for. And I've represented this here as a bar. You can see that on the left-hand side of this graph in the past, because this is historical data and it doesn't get updated in the code all the time. So if you're designing a code minimum building, it is using old data. And you can see, just looking at this graphic overall, that's not representative of what the future climate is going to be like. So for us as designers, even though the code establishes a minimum, we need to be thinking more proactively about what that future is.
Okay, so here's the time frame for any new project extending from now into the future, maybe 100 years, 60 at least as a minimum for designing new buildings, and depending on what building type, might be even longer than that. So our challenge as designers is to think about, what does that future climate look like? We want to, of course, be contributing to the global effort to reduce emissions. We want to help be on that blue path, but no matter how successful that is, we also have to think about this. And so we have a big question here about how will we adapt existing buildings? How will we prepare any new buildings for the future? And so again, this sounds like very complicated and difficult to deal with. But what I wanted to highlight is that we have responsibility as designers of the built environment for addressing both sides of this, mitigating emissions as quickly as possible. And that is something we can definitely do. You're going to hear all about that this week. And then also planning for that future so that we have shelter provided for our society, no matter what scenario happens. And that's also something that we can be very confident that as designers, we're making a difference every time we consider the long term. Okay, so that's the positive part. There's lots of room for us. Okay, so we have to do these two things: mitigate short-term emissions, and we also have to adapt the building to the changing climate over the long term. Those are the important pieces about our role with respect to the climate crisis. And when we're setting goals for our projects, we should all be thinking about how we can act in that longer term. Just a note on climate, I was showing you graphics there that show global mean average temperature. That's just one number, and it's not really directly related to things that affect buildings. But if you were to break that down into heat, moisture, wind, different aspects of the weather that our buildings experience, you would consider as a designer, how do all these changes affect the occupants of the building now and in the future, and how can we design for those things? Just a quick example, in the GTA area where this project is located, we're expected to get much more of these heat wave conditions over the lifespan of the building that we're going to be talking about. So we're going to go from something like 7 to 10 days of really hot temperatures linked together in groups of 4 or 5 days over the summer, to almost a continuous 60-day period of time in the summer that will have those elevated temperatures by around 2060 or so. That's like one piece of this. So how would we design buildings that have those kind of conditions? We'd be looking for examples maybe from other climates that are already, other locations that already experience those things, and integrating it into our design. Okay, so here's a sort of map that you can think about. And I should add too that I'm going to send a PDF of this presentation immediately after finishing, and so you'll have access to all of this as well, and you can look at it in more detail. So some starting points then, if we're thinking about the design, there's kind of a hierarchy that we'll be following as you talk to the subject matter experts this week, and then also thinking about the design charrette that you'll be participating in, that goes from the kind of directly related to architecture parts, the passive elements. These are strategies that you can use to reduce the building's energy use, to take the best advantage of the climate that is available, the energy flows that are available, and then things that are indirectly related to the building, more the active systems in the building. And this hierarchy describes the sort of more permanent, bigger picture changes that have a large impact on the project, and then putting them in order with the things that become refinements. So if you look at this model, one way of thinking about this is what you do with the architecture of the building has the biggest impact that decides how you respond to the environment. And then the active systems, the mechanical systems, are really just supplemental. If you were designing the same building in California, for instance, maybe San Francisco, you might not even need active systems in the building if you design it well using the architecture. And that's how we've done things for thousands of years before. We just need to think through this. So there's one way of thinking about setting goals for your project. Start with these top level items and then start considering the issues lower down. There are other types of goals, and you'll hear about these this week if you're not already familiar with them. There many municipalities in Ontario have, and other jurisdictions in North America have, a green development standard. Here's an example from Toronto that has a tiered approach, or a step approach. Each one of these tiers represents a level of performance for the building on energy and resource use, greenhouse gas emissions, that gets more stringent over time. So tier 1, tier 2, tier 3 all have a date associated with them. So as we build buildings in that period of time, we have to hit these targets. The 3 columns here, these are pretty common and are now being integrated into the National Building Code for Canada. The total energy use for the building, so that's all the energy that's used for any purpose inside the building. This is what the energy model for the building is going to be looking at, and you'll see that in the design charrette. And so the amount of kilowatt hours per square meter per year is going to have to decline over time. The thermal energy demand intensity target is a subset of the total energy that just relates to the building enclosure. How it's sort of like the miles per gallon for the building, like how much you can get out of just the passive elements of the building. And so there's a target for that as well. And the GHGI is greenhouse gas intensity emissions, which are related, but more focused on where you get your energy from and what the greenhouse gas contributions of that energy are. So if you use fossil fuels, for instance, that the greenhouse gas emissions are going to be high. If you use electricity, especially from renewable energy sources, the greenhouse gas emissions are going to be low. And so what you can see in these standards, these targets, are a slow progression year over year towards essentially zero emission buildings. And that's the path that many municipalities are on. I would just point out that this is also just a transition. If you are entering the design and construction profession and you're thinking about your career extending past the year 2030, you don't need to worry about the threshold so much, these tiers. You just need to look right to the end. And so a lot of what we're going to be talking about is focusing on, okay, how do you design buildings to reach the target that's at the end of this path? In the industry, a lot of what we're doing right now is trying to reach each one of these thresholds, but you can know that we're thinking much more long-term. Okay, so that's maybe some conversation about different common targets and maybe where you might find those. So you early would set targets for, what's an appropriate total energy use for the building. Maybe you could use the Toronto Green Standard as a guideline. You could look for example buildings that are sort of best in class. You wouldn't want to ignore those other two. And you'll probably, as a result of that, come up with information about, okay, well, we need an exceptional building enclosure. The building itself needs to be designed very well. And so we'll set a target for that. And maybe we'll be thinking about this whole life cycle carbon, not just the emissions associated with the operational phase of the building, but also with the materials and throughout its whole lifespan. And I'll talk a little bit more about that in a second. I see there are a whole bunch of notes in the chat there. Bettina, are there anything that we should be talking about now, or are you answering those as we go?
Yeah, we'll answer them as they go, and if there's something specific. I think Bryn has just put in a very important part. If we're talking about regulations that cities impose, that municipalities impose, let's be honest, there are limits to the enforcement, unfortunately, and we even have the case right now. I hope most of you are aware that there's a consortium called ResCon, the Residential Construction Industry, and they're actually suing the city of Toronto for imposing their green standard. So,
yeah, that's all very true. And you know what? It feels like a bit of a circus right now in the industry because we have these standards. People are trying to push for them. They become very politicized. This long-term perspective that I'm talking about right now, like, you can ignore that circus. We don't have to participate in that. As designers of the built environment, we know what needs to be done. And we have a responsibility for designing the buildings that are appropriate for our society for 60 to 100 years from now. So I like this because it's so anxiety raising to get caught up in the politics of this, but we don't actually have to play that game. Buildings are long term. Okay, so let me show you a little bit about how this has changed over time. I was talking about operational emissions and targets that relate to the embodied carbon associated with a building. Here's a case study from a high performance building that was designed not too long ago. It actually started in 2016. So let's say that the design process was almost about a decade ago. That's not a long time for building. But at that time, and this is an institutional building, so it's a little bit different than the one that you're going to be talking about before. At that time, all the conversation was around, let's get a zero energy building. And that was about the operational side. Like we'll build it, and then when we're running it, it's going to use as few resources as possible. And there were some other goals for this project, like it's at a college in Hamilton. This is the Joyce Center for Partnership and Innovation. And it was designed to be a living lab to really show the sustainability aspects of the building itself. But a key aspect was this energy, the energy used in the building is equal to the energy that's generated on the site of the building itself. So that was the target. And then as a stretch goal, we were thinking about, okay, so how does like all the energy associated with the materials fit into this? 10 years ago, we were just starting to ask that question. I'm going to send you the PDFs of the slide, so I'm not going to spend a lot of time talking through this, but here's the building in the center here. You can see this is an illustration of some of the mechanical systems. There's a geo-exchange system that takes heating and cooling, basically uses the ground as a heat sink for heating and cooling purposes. Much more stable ground temperature means that we can use that energy in the building in all seasons. It's fantastically efficient, electrically driven, so it's very low carbon to begin with. This works for, it's also connected to these PV arrays that are on the roof. And in this graphic, they're not emphasized, but you can see on the roof plan, there are these like inclined planes. And in the graphic, just on the photograph, you can see these big angular planes that are screening the entire building. Those are photovoltaic arrays that are installed on top of the building in order to generate power on site. So that is driving some of these mechanical systems. Huge amount of work went into, and again, you don't have to read everything that's on the slide, I'll just explain what's here. A huge amount of work went into design, looking at, on the left-hand side, a whole bunch of different combinations of building enclosure plus active systems in the building. What is the cost? How much energy is going to be used? What kind of photovoltaic array, what size of array to generate electricity is going to be necessary in order to accommodate all of that energy use, and then working that into an actual budget for the project. Very, very intense design work. And you're going to see like kind of an example of that process for the design sure. The summary of the story is that with all that work to try and figure out how to reduce energy use and generate more, we started measuring the performance of this building shortly after it was built. In blue, you can see the estimated amount of energy consumption. In light blue is the estimate, dark blue is the actual amount of energy consumed. So more or less in line there, month by month. And then to balance that off is the energy generated. In light orange, the estimation for how much energy could be collected from that solar array on top of the building. And then dark orange is the actual amount. Overall, you can see that some months, especially in the winter time, the building uses more energy than it's able to generate within that month. But on the year overall, there's a surplus of energy. So, this is like mission accomplished for this. Something like 90,000 kilowatt hours of additional electricity was generated by this building beyond the energy that was actually used. Okay, so that's pretty good according to the original goals. So on operating emissions, like the actual operation of the building, we can say that the energy used is less than the energy generated. That was a measure of success. But on total emissions, if we were to think about all the energy and environmental impact that went into the materials for the building itself, well, okay, we have to look at that also as a separate thing. There was a life cycle assessment done for this building that was pretty preliminary. Like you can see the elements here are just really the structure of the building enclosure itself. So not including mechanical systems or interior finishes, but trying to get a sense of how much carbon emissions go into that building as a whole. And the total was something like 4.5 million kilograms of carbon that's committed to the building on day one. So, okay, if we were really to think about reducing emissions, it's not just the operational side. We have to account for that embodied emission up front with the new construction of the building. So we can say that that's approximately equivalent to about 500 kilograms of CO2 per meter squared. If we look at how much extra energy was generated, well, maybe we can offset some of that embodied carbon as well. So very roughly, we could offset about 70,000 kilograms of CO2 per year with that extra electricity. And it would take about 60 years to effectively pay off the carbon that was invested in the building at the very beginning. So that's a long time to get to zero. 60 years is like, remember the time frames we're talking about here to have an impact on the climate crisis? We've got like decades left, like maybe 20 or 30 years to reduce our emissions as drastically as possible. And so this is maybe something we could do a lot better at. Now in 2016, 2017, 2018, the industry was not really thinking about these issues. If we were to design this building again, we would be using less aluminum, less concrete. We would be using specifically materials like mass timber construction, for instance, as many biomaterials as possible that could not only have a lower embodied carbon impact, but also could sequester carbon from as part of their growth in their original form and lock that up in the building. Those would all be changes that we would make right now. So these are all differences that have happened in just a short period of time. I've got another way of illustrating that sort of whole life cycle for the building. And again, it's connected to this long-term thinking. I'm encouraging you when you're setting goals to think about the whole building life cycle, because it's going to help you address these big challenges. So here's an example showing similar information. We've got the operating carbon in orange, and we've got the embodied carbon or upfront related to the materials in gray. And this is organized by a decade of a building's service life. So this is for an office building using kind of a conventional design for the building. And this is maybe a 60-year service life. So that's the idea for a building built right now. So here's what it looks like as a whole. If we were to do a conventional building design, and so let's say this is something that, maybe 10 years ago would be common in the industry, most of the carbon emissions were related to the operating phase. And that's why our codes and standards and a lot of our ways of doing analysis are set up to deal with that operating emissions. But we've been rapidly changing things to reduce those emissions. So first off, the building codes and other standards like the Toronto Green Standard have been pushing for very energy efficient design. So right off the bat, a building we were going to build today would have much lower operating emissions. And then the whole life cycle, that whole 60 years, it's more like 50-50. So without that energy efficient design, we would be having to focus much more on the operating side. But now that we've taken these steps to make the building much more energy efficient, the embodied carbon becomes more of an issue. If we were to take that same building, very energy efficient, and switch it to all very low carbon electricity, you've heard probably a lot about electrification of buildings in the industry. Well, then we can even further reduce the carbon emissions associated with that energy use. And so on the life cycle side, look, it's almost like 90% of the carbon emissions are related to the materials themselves. And this changes a little bit now depending on where you build the building. In Ontario, this is a table showing all different provinces and the amount of CO2 per kilowatt hour of electricity consumed. In Ontario, the grid is actually pretty clean. It's going to get a little more carbon intense over time. That's the prediction. But in Ontario, we would say that we really have to focus on the material use. Design for a very energy efficient, resource efficient building, and then think very carefully about the materials. If you were to go to another province, like I'm sitting in Nova Scotia right now, and so my laptop is plugged into the electricity here, and its carbon intensity is 680 grams of carbon dioxide per kilowatt hour. Now that's going to change over time. We're going to decarbonize each one of these provincial grids. But this is just to say that when we're thinking about the operational phase, it really matters where the building is and what the energy source is that you're connecting it to. And as a designer, thinking back about this whole life cycle graph here, this helps you with understanding where you need to put most of your effort. This last slide in the sequence here just shows that if you were to take the next few decades and just focus on those, not even worry about the end of life for this building, it's above 90%. It's a lot about the materials that we should be thinking about. So in this week, you're going to learn a lot about how to achieve that very narrow wedge for the low carbon energy design, energy efficient buildings, low carbon power, and then in addition to that, you'll find some focus on the materials. And I just wanted to make the point too that although we're sort of equating everything to carbon because that's how we talk about our response to the climate crisis, we can't really separate our material and energy flows from the environmental and social impacts that also occur when we extract materials for our building projects. So if you picture this building on the left-hand side, and that's what you're designing for, and by the way, Manitoba Hydro Place is one of the best buildings that we have. It was designed almost 20 years ago, and it is amazing from an energy and carbon perspective on the operating side. It's one of the leaders in its class, but it's also made of aluminum, glass, and concrete. And so if you're picturing architecture that's like that, you can't really separate it from the social and environmental impact of the extraction of that material. And that is part of the environmental impact that we're also trying to measure and minimize as we do our design work. Okay, so some more big picture thinking that sort of relate to goals. You'll find lots of information these days about life cycle assessments for building, about the environmental impact of different materials. Here's some information that you can dig into this in more detail, but just even looking at one category of material, just insulation. So many different options. Some of them are not commonly used, but we're going to learn to use them because they have much less carbon compared to some of the products that we're currently using in the market. So that's a dynamic that you're going to be chasing down as well. Okay, so that's a big picture on when we're thinking about the building as a whole and really doing everything we need to do to mitigate those short-term emissions. Think about how the building adapts to the long term and really consider that whole service life for buildings. All right. Those are some goals that are very specific and numeric based, and we'll deal with those. But all the way along, you should also be asking yourself that question about social and environmental impact. What is, what are we thinking about in terms of net positive for both humans and in environmental terms as well? One way to maybe start down that path is to think about how the quality of the design work with respect to what humans need. You may have heard about biophilic design. It offers a framework of understanding that direct experience of nature, other things that humans need in order to be comfortable, happy in the shelter that we provide. This is another way of maybe setting targets that are not just numeric, but also more holistically address what humans need. So I would offer that as a possibility. There are other targets that you might at the beginning of your design work think about. So on that environmental quality part, talking about daylight, thermal comfort, appropriate levels of sound, visual comfort as well. All of those things might be just as important for us, or should be just as important as the carbon and energy related goals for a project. If we're thinking about the whole lifespan of the building, thinking about reuse and adaptation of buildings, thinking about the durability of the materials that we choose, what happens at the end of a building's life, we can actually design to retain as much of the building material and reuse it in a different building in a circular format. That's possible to do, and we're thinking more about this now rather than just throwing it all out and having to extract new material and along with that have more social and environmental impact. And we might think also about targets that relate to the resiliency of the building over the long term. This is that adaptation to future climate change and is connected to our responsibility to provide shelter in any one of the potential futures that we're faced with. So I would encourage you to think about all of these things early, just as you're intaking information this week and understanding what needs to be done with the building, to be thinking about, are we also setting goals or objectives that relate to these other things? And it all, of course, has to be wrapped into great architecture. And I'd like to offer you some examples of this, because this is really the challenge, is not just to do, hit these particular goals, but bring it all together into something that people really want to live in and is going to be of value for the long term. So I'm going to show you some examples, and I'm going to relate it back to this, the project that we have to deal with. And you may have seen this information, or if you haven't, you're going to see it very, very soon. This is the project site and a proposal for the new construction in a multi-unit building, some townhouse buildings that are going to go together, and adjacent to a former school building on the same property. I'm, thinking about people, thinking about some of these big picture things that we need to do, just going to do like a tiny little bit of analysis here and compare it to some examples of great design that tie some of these other things together. Here's some basic statistics. I'm taking a guess. Some of the briefing information says it's probably about 50 to 60 units. I'm going to guess that they're mostly 2 bedrooms, because that's typically what we build in, if we're talking about affordable housing right now, even though we know the needs are more of 3 bedrooms and 4 bedrooms. But let's give it a mix of 2 bedrooms and 3 bedroom units. If that's what we're going to build on this site, and I'm just taking the area of the site that we're going to build on, we're probably talking about providing housing for something like 400 occupants per hectare. That's the kind of density. And that's important, because when we're thinking about our use of resources and the quality of design that we provide and thinking about the long term, this is a key way of thinking about how we can minimize that material and energy total carbon for the building, while still providing as much quality living space for as many people as possible, addressing as many problems as we can. Here's some examples of buildings that I think might be worth considering, that tie together a lot of these goals. A project in Montreal, and Montreal has so many projects that are sort of down the road here. This is not a great picture of it, but it does show the position of the project immediately adjacent to a very busy road, just at a corner, not unlike the property that we're talking about right now for this development. You can see in this overhead view, the marker shows the building project, kind of a north-south rectangle there, major street immediately to the north, and a fairly busy street to the west as well. But filling in a corner property in what is otherwise a low-rise, lower density neighborhood. So this is really increasing the density in that case. And here's what this project did. Rather than trying to replicate the exact same density, they expanded the number of units pretty dramatically. And this is like a much higher density than what was proposed. Is 4-story units, and there's some special things about the way that this is arranged. You can see very little direct access to the unit right on this busy street. There's like one door that leads in more deeply, and you can see these kind of like slits between the buildings that lead into courtyards. That's really where most of the address of these buildings are created. And what happens is that there are all these private spaces for people, for community users, created in the center of this space that is much more densely built. With some examples of what this looks like. And again, you can find more information about this project, and you'll get the PDF of this, but you can see that sort of courtyard in the middle allows for a lot more density for the building, but a lot of public amenity spaces like shared bike storage, shared recreational areas in the middle of the project as well. So a way of, I think, combining some of those other human-centric views. You'll notice if you actually go and look at the plans for this project, and you can find them on the architect's website, all of these units are larger and they have more daylight access on 2 sides of the building, totally different than the kind of conventional approach. And they also result in a lot higher density. Here's another project from Montreal, and I'm like quite happy to say that Montreal is doing this better than the GTA. So I didn't used to think that way, but I think we should be looking for these examples as much as possible. This is the Windrose project in Montreal. It's actually student housing, so it's a bit of a different profile, but it's built as part of a much more dense community in a suburban location. So that's why I think it's maybe a good thing to think about, like, how did the designers handle that challenge of building in the suburbs, but increasing the density and creating spaces that are fantastic for people to live in. And so you can see the building is a bit of a block. Inside the building, there are kind of courtyards. You can see in this overhead photograph, there's a lot of construction happening along here. But this building that I'm pointing out is just at the left, upper left of a whole series of courtyard style residential buildings that have some of the characteristics of the one that I just showed you, and definitely emphasize people and access to light and access to community recreation spaces and community engagement spaces over, for instance, parking and cars, right? So these are like very, very good combinations. The building that I'm talking about is the one on the left. It has cafes down at the bottom. Eventually, this view that you look at down this pedestrian street will be filled in with other buildings. If you look deeper into this particular building, this is from the architect's website, you can find out some information about how they arrange the units around courtyards. Pretty interesting to achieve better living space with higher density. But as you walk down this pedestrian street, you'll see that each one of the buildings, much larger massing, but contain these kind of pockets where they go into courtyards that have much more internal circulation space. And again, the payoff for the occupants check a whole bunch of those boxes on our hierarchy there, right? Like access, arrangement relative to solar orientation and climate, access to light, to passive ventilation, windows on all sides, allowing for larger units. And they're reconfigured in unconventional ways around courtyards with sometimes exterior circulation. Another project as we continue to walk down this street, that's the outside. The inside focuses on a larger courtyard. On the left-hand side is a community space that's built in that looks like kind of a planted area on one side, but the wall where there are windows and doors actually leads into like a yoga studio and a bike repair shop that have been positioned right in there. It's like maybe a good match for the community side as well. Anyway, I just present all of these as examples of goal setting that goes beyond just the basics in terms of energy and carbon. And if we were to compare on some of those key numbers, like the types of units that are provided, the density, the amount of occupants that we can house with the amount of land that we use, just as a measure of how efficient these buildings are. That first example is like 50% more occupants per hectare than the sort of more conventional proposal. So to me, that tells me that the site is even smaller. We could probably go larger with this in terms of density. And then just to compare the last one here, again, small site, and we have like 1,400 occupants per hectare. Like this is just to say, each one of these projects offers so much to the people and the community that go beyond just those carbon and energy metrics. And they can do it in a way that actually increases density, and they're all in suburban locations as well. If we think right from the beginning about how we might shape this project, I think we could be very bold and aggressive about doing more and getting more for people over the long term. Okay. I think that's basically all I wanted to say in terms of setting this up. I mean, I'd finish by saying that, this is a complicated task, right? Like integrating the low emissions performance with great architecture, balancing out the needs of people over the long term. It's really important that we focus on this so that we don't end up building an awful lot of construction that is going to be quite awful for people in the distant future. We have to deal with that right now, and we have an opportunity. So as designers, this is the really positive part. It's complicated, but we can directly engage with this challenge of global significance. And this is going to be your whole career to do this, but you can be assured that if you attend to these big picture long-term things as the context for your goal setting on your project, you will be making a positive impact with every decision that will have hundreds of years of impact for our society. So it's a pretty big thing that we can do, and it's like starting now on Monday. Okay, so I think I finished with 5 minutes to spare. So I could take questions if you like. I'm not sure what's been happening in the chat, but you could let me know if there's anything you want to chat about. Okay. It could also be that everyone is just so excited about this challenge for the week and all these things, these amazing things that you'll be able to do with the project by Friday.
I have a question.
Yes, go ahead.
For net zero building, does the energy source necessarily have to be renewable? And for example, solar panels and something like that, or other source of energy can be used for a net zero building?
Yeah, absolutely. And there are many sources of energy for buildings. We tend to just think about fossil fuel, usually gas and electricity, because those are the ones that are networked in our cities and delivered to every single building site. But of course, through history, that's not the way we've done things. And many communities have actually started finding different sources of energy to tie into that network. So the example of that institutional project that I gave you used photovoltaic energy on site, so collecting solar energy. It used some for heating hot water in a building, some for powering electrical needs, which included that geo exchange with the ground, which is not like exactly renewable because it's not generating electricity. It's just like a super efficient way of getting heating and cooling needs. But what you're seeing there is really a mix of strategies. If you were to extend that a little bit more, this may not be the project to do it, but you could look at other fuel sources, right, that might be lower carbon. In a more rural location, an automatic choice would be if you have a wood lot that you can sustainably harvest wood from. Well, that's kind of a zero carbon emission because it's sequestering as it grows and it's releasing carbon, but at least it's neutral. But there are other things we could think about as well. Right now in Ontario, I showed you the numbers about how clean our grid is. The reason for that is because the grid as a whole is integrating in things like wind energy. There's a lot of nuclear power in Ontario, which is considered to be clean in the short term, right? So those are examples of other energy sources that we could think of.
Hey, I have a question.
Go ahead.
Similar to the Toronto Green Standards or the NECB, do other Canadian municipalities or provinces have their own building performance standards or like tier codes?
Yes, almost all do. So some provinces use the National Energy Code for Canada as like the kind of guidance that is adopted by each one of the standards, and that has been changing pretty rapidly. So in effect, any province that uses the National Energy Code for buildings has that in place. But there are others that are leading in different ways. So British Columbia started with the city of Vancouver having a step code that was very much like the Toronto Green Standard to push people forward. Now the entire province has a tiered system that is, better than the National Energy Code. Quebec has a similar system that pushes towards decarbonization of buildings and reducing energy use of buildings. So you'll find some version of this in almost every location in Canada. There's a big effort right now to change at the national level all of the codes and standards so that everything moves forward faster. But again, I just want to emphasize the point that all of the, even building codes, even though they're like solid regulations, they change slowly, right? And they're subject to political questioning and discussion. And so things may not change as quickly as we want, but we don't build minimum buildings, right? As designers of the built environment, that's just the lower threshold. We do all sorts of things above and beyond that for our clients. And so there's a lot of space for us to act on any given project. We don't have to wait for the building code. Okay, so I just want to keep in mind that you're always free to do more as long as you can find good ways of doing this for your clients. I see another hand up there. Go right ahead and unmute.
Hi. First of all, thank you very much for the great presentation. And my question was, you kind of I mean, you kind of showed that some of the concepts in Montreal have like these open spaces, and I'm assuming it's meant to promote more community, like the sense of building more sense of community, giving a people to like sort of take full advantage of open spaces. I was wondering, how is there any form of role that like the community's voice or tenant engagement that plays into future sort of building management practices, or uh, like how do you adapt to that, like similar to climate change adaptation that you were talking about, something you do long term, but when you're making the building, you don't know the behavior or the insights of the people who will occupy it. So how is that sort of embedded, or what kind of part can it play once the building's operational?
Yeah.
So
Well, on the question of community engagement here, I would say that we can't do much unless we have the engagement of the community to address this crisis quickly. And when I say the crisis, it's like the climate crisis, but also we want to be building much more housing for people that people really want. So let me give you an example from this project. We've got a former school connected to a bunch of existing neighborhoods, and we're putting a lot more people right on this corner of a busy intersection. I have a feeling this is because this is the conventional approach that the owner of this project is not going to want to build too much because they don't want to disrupt the community that's happening. But if we want to make the best impact here, we should be going beyond the building. And this is going to require engagement with the community and conversation about it. We should be asking for things like we shouldn't have more parking. We should have less. But in order for people to have less parking, and have the option of not having a car, which by the way is a big affordability. If they forget about the building, not, having to own an automobile would be a major thing. Well, we have to be asking for more transit in this area. That has to be part of the project. We might need to be thinking about other options like car sharing, for instance. Like, in downtown Toronto, the car share systems work on a ratio of about 1 car for 35 drivers. When we plan suburban buildings, it's like 1 car per person, and that's how much parking we provide. But what if we could get a car share system that had 5 or 6 cars to cover, 100? This is like an argument for having more people, but also an argument for connecting with the community. How about that cul-de-sac that's at the top that engages with the rest of the community rather than having more traffic on that street? Let's put like 6 car share spots there. Maybe people in the community can be engaged in this car share service as well. There are so many different ways where we could talk about understanding what the community needs and also presenting a vision of the future that is like much more cohesive and engaged and offers more than just what is the conventional approach. And I find that these things often overlap pretty explicitly with the way that we do good design work. And those Montreal examples that you referred to, I think they're great examples of where that design thinking has resulted in very different buildings, partly because they're designing for the community specifically and doing both the high performance and better for people. So we got to be bold. We got to be bold to do it. Yeah, go ahead.
I have a question. Well, first, thank you so much for all the information. I want to ask about district energy systems. I'm not sure if you are familiar with these kind of systems, but it's like a system where we provide heating and cooling on a central scale, and instead of having standalone HVAC system for each building. So my question is, will we be seeing more of these systems in near future, or are they effective, or what do you think about these systems?
I think the answer is going to be yes. And you're going to hear from some experts this week that know more about the systems than I do. But if you're thinking about the big picture, yes, we're going to be designing buildings that use much less energy, which means we don't need to have an energy supply system for every single unit in the building. And makes sense to start grouping them together. It also makes sense to look for connection. Think about this community center. Probably it's going to exist for a number of decades before that site is redeveloped, like the former school I'm talking about. There may be a way that we can connect the energy use and needs of these different buildings together. And there are examples where even at the suburban level, like where we have the most dispersed small buildings, people are starting to think about how to bring the energy systems together so that they can be more effectively operated. But I just want to say it follows that pyramid approach, right? Like if you reduce the loads for the building as much as possible, then you have less energy to worry about, and you have many more options for very low carbon, very efficient approaches like a district system. Okay, so I think we definitely will see a lot of those. My university, the University of Toronto, just became like the most sustainable university in the world because they put in a geothermal system that is connected to their district energy system, and their carbon reduction is like half what they were using before in a very short period of time. And that is one example of what we're going to see replicated in many different cases. So I would encourage you to look at it.
Yeah, I even read about other systems called smart energy system and climate neutral society, where they integrate the energy sector with transportation and even aviation. And so the whole energy needs for a community will be like centralized and controlled.
Yeah. This is an important perspective, and I would just very briefly highlight, we used to think about buildings as separate things, and we would try and optimize them by themselves. We can't do that anymore. That discussion about the connection to energy sources, we're really talking about the community. Think about the little discussion we had there about transportation. If you were to measure the transportation-related carbon emissions for a suburban community, it would dwarf the carbon emissions of the building. It's like 4 or 5 times as much life cycle carbon associated with people driving back and forth towards the building, which is one reason why when you start thinking at the bigger scale, you see these connections, and you'll see things like, we should not have 101 parking spaces provided on the site. We should be providing 101 dwelling units and saving that space for people, partly because the carbon emissions are going to be huge if we continue to build our suburban communities without options for low carbon transportation. So there's no difference in a way. It's the whole built environment that we are working in.
So I have a quick question. In regards with the carbon footprint reduction, I was wondering because as the design of the buildings are becoming developed, I'm gradually seeing that they are coming up with new engineering materials that are being replaced and are far more advanced and more efficient, especially with the foundation of the buildings. I was wondering, in the future, is there going to be like new building materials that are engineered that will be created and will replace all carbon type materials? In this
Yeah.
case, rather than using carbon material to build the building, we can use more sustainable energy engineered design materials to create the building that has zero carbon in it.
Absolutely. There's a lot of work being done on this right now on the material side. So some of the ones that we use all the time, like aluminum, glass, concrete, and steel, there are low carbon alternatives and technologies being put into place to replace those. One challenge is that it's going to take decades to get those into the industry in significant numbers. Another pathway is substituting materials for biomaterials. I was noticing in the chat there was some conversation about sheep's wool insulation, and there are amazing things that we can build buildings out of. And that's not so much an invention of new materials as it is learning how to reuse some materials that we used 100 years ago or 200 years ago, like before we had all this energy intense industry to provide materials. So there's like kind of an old and a new aspect to this, but I want to emphasize that the short-term reductions are not going to be waiting for that. We're going to be like the biggest things like that, that density number that I was showing, number of occupants per hectare, like reducing the amount of material and increasing the number of people that we can house with the same amount of material, that has the biggest impact right now, right? And we can make those decisions immediately. And so I would say, yeah, like change will happen, but don't wait for it. Remember that in the big picture, we have decisions that we can make as designers right now if we focus on that whole life cycle carbon issue, use less materials, get more out of them, and we'll be well on the path. And the material innovation will catch up over time.
So another question that I would like to check is that when the projects are being started, when they bring the vehicles to the construction site, and when they start working on the project after the excavation and all this process, because I come from civil engineering technology background, I've seen it. All this work has some form of an impact on the carbon footprint itself.
Melanie LeBlanc, is that? Oh, I'm so sorry.
Well, that's fine.
That's okay.
I'm so sorry because we're a minute from the next presentation. Farouk and Alex, maybe what I could do is go ahead.
Let me just do very quick. It's about 15%. So it's 85% is in the extraction and processing of the material. And yes, the construction does make an impact, but the activity on site is relatively small compared to where we get the materials from. And so it's 11 o'clock now. Maybe we should leave it at that, Bettina. I think my email address is in the slides. It'll be in the I'll send the PDF right now, and I'm sure that will be circulated. But I wish you all very well on the work this week. I would just encourage you to be as bold as possible in setting goals and pushing the project forward, because we really need you to do that.
Thank you, Alex. And I'm so sorry to interrupt. That was amazing. We appreciate you guys so much. Diana.
Yes, now, so thank you again, Alex. Thank you everyone for taking a moment to complete the polls. And now I'm happy to pass it on to Meaghan Macdonald from the City of Durham, who will be discussing the 600 Town Line Road project and with all of you. Meaghan, if you could please take it away.
Good morning, everyone. Can you hear me okay? Can I get some thumbs up? Perfect. Okay.
Yes, we can hear you.
So I just joined at the end there, so it sounds like you just had a really engaging session, which sounds wonderful. I'm just waiting for my colleague, Andreas, to join. So once he does, the two of us
just arrived. He'll be joining in a second.
Oh, perfect. Okay, great. We are used to Teams meetings, so we're used to all of a sudden waiting for it to pop up to tell you have to join. And so every time I have a Zoom meeting now, I'm like, oh goodness, I don't get a prompt. I have to go. So I will introduce myself. My name is Meaghan Macdonald. I am the manager of affordable housing development here at the region of Durham. The region of Durham is an upper tier municipality. So we have 8 lower tier municipalities underneath us. So many of you might know City of Oshawa, the City of Pickering, Town of Whitby, Town of Ajax. All of those, the upper tier is the region of Durham, and we are responsible for housing on behalf of the region, in particular community housing. And so Andreas, I'll let Andreas introduce himself. He has joined.
Hi, everyone. Thank you for coming. Andres Bautista. I'm a project manager at the region. I have a background in architecture. I'm an architect within the private sector for many years and public sector for many other years. So excited to be here, let you guys know what we've been working on, and go from there.
And so I'll just quickly, Andreas is going to take us through the building, but just before we go to that, I just want to give you a bit of history about the project and what we're looking at. So back in earlier this year, Regional Council gave us approval to purchase a piece of property at the 600 Town Line in the town of Whitby, but it's right on the border of Whitby and Clarington. So it's right at the end. And the existing property was, it was actually operated as a Grandview Child Youth Center. And so it had a lot of, the existing building had rehabilitation for children and youth. So it has like a pool, like a therapy pool in it. And like, it's a really interesting building. But part of the reason why we got approval to purchase the building was because it had been determined there was enough space on the property. Yeah, see, Andreas is so good. There was enough space on the property to be able to likely add some housing. And so just to take a step back for a second, as I mentioned, the region is responsible for community housing. And in 2000, when the province of Ontario downloaded the responsibility of housing from the province to the municipalities, it created a bunch of local housing corporations, and each municipality, each service manager, there are 47 of them across the province of Ontario, is responsible for a local housing corporation. And so some of you might have heard of the big ones like Toronto Community Housing Corporation or Ottawa Community Housing Corporation. In Durham, ours is called the Durham Regional Local Housing Corporation, and it owns 1,292 properties across the region. And we, the region of Durham, is the sole shareholder for DRLHC properties. So we are responsible for it. So we have an entire staff team that is responsible for owning and maintaining and doing all the tenant support for those properties. So when Andreas and I started, our roles here at the region are fairly new in affordable housing development. This actual office is only a year and a half old, and it was the region saying we need to actually take control of managing and developing affordable housing. And so Andreas and I we've come on just not too far apart, and our job is to actually revitalize and rebuild some of those DRLHC properties. Many of you might have heard of the big project that the TCHC has done in Toronto. The biggest one everyone talks about is Regent Park, where they've done a huge revitalization of their community housing and created a mixed income community where there's, rent geared to income, so low income rental housing, as well as market rental housing and condo housing all intertwined. We're going to be doing the same thing with a lot of our properties. Now, this is actually not a DRLHC property. So this one's really exciting for us because this is the first time. So a lot of the projects Andreas and I have been handed are revitalizing things we already own and replacing it and adding more housing to what is like just rent geared to income housing. So we're taking those sites, we're intensifying, building new and adding in, affordable rent as well as market rent. With this particular site, we advocated when we bought it and said, we want to put housing on it. And additionally, we want that housing to be operated by the DRLHC. So this is the first project in the region we're doing right now where we're actually adding to the inventory of the DRLHC, which is very exciting for us. So that's just the preamble I wanted to give. I'm now going to turn it over to Andreas, who's going to talk to you about what we're hoping to do on this site.
Right, okay. So like Meaghan was saying, we are in north of Oshawa. Yeah. And then we're on Town Line and Bloor. So there's an existing one-story building right here that we're not demolishing. And there's a parking lot here with some green space along the front. The original design, which we are taking a step back from, but we'll still talk about it, essentially had a four-story townhomes, stacked townhomes along Town Line Road, and then we had a four-story or so linear building along Bloor Street. So it looked like this, and we were trying to aim at getting 50 to 60 units. What changed from the original layout is that we added a street. So this is what makes it interesting. We had this sort of street here because we're trying to avoid this connection to the residential here and also creating a connection to Terry Fox Park. So the existing building here is going to have a bit of a smaller playground footprint right now. If you look at the Google Maps, it's kind of a bit bigger. So we're going to reduce all of this, probably introduce some parking, and then currently we are studying which way we are going to situate the building. The latest design was completed by LGA. And this is just the current orientation. I'll flip it over in a minute, but where the townhomes used to be is where we are going to be putting a 4 or 5 story building. And we're still trying to keep this kind of loop and keep the parking that's here and reintroduce more of an animated landscape along the south side so that we can connect it to either the existing building or connect it to the new proposed building. So what we really want to take away from this workshop is either, first thing, if we put the building on here like we originally had it, or versus it being along the north-south, we'd like to have a sense of what happens as the building, which side is more efficient in terms of energy efficiency, right? So if it's facing north-south or if it's facing east-west, what happens to the building envelope as the sun goes from east to west, what happens to the units inside. So that's the first takeaway. The second takeaway we'd like to also explore is seeing if we can add balconies to the building. So what happens between a building that has no balconies versus a building that is full of balconies, and how that affects the building envelope and its efficiency, and what type of options we can introduce. I'm just gonna flip this around. 1 second. So I'll just walk through the building right now. So one thing we're doing is introducing an underground parking, and it's going to be an unheated space. We'll jump to the section in a minute, but essentially there's a core with elevators. You come down the ramp like that, and then parking is on either left or right. Set of stairs on either side of the building with mechanical, electrical, unheated space. So it's going to be open section wise. Ground floor. This is south this way. South facing lobby with an office, probably a little bit bigger, like so, and then elevator core and vestibules. You come in, a set of stairs, and amenity space. So we're splitting the building as it is right now into a public area and then private for bedrooms, 1 and 2 and 3 bedrooms, with a stair at the back. Second floor, you start to introduce a shared balcony right across the elevator lobby. Shared balcony because, again, we're not introducing balconies to every single one of these units, but if we could study at least one of them, let's say if the 3-bedroom had a balcony, inside balcony or outside balcony would be great to know. Right, so this is the section. You can see the open air sort of parking level. It's half sunken building, so we don't need to heat the underground except for the vestibule and the elevator. And that's sort of the form. It's very simple. We're not doing any type of, these are the starting points. R20 for the wall, R40 for the roof. It's a brick building, flat roof, and half sunken P1. Any questions so far? I'll take that as a no. I wanted to also show you guys a building that we're working on that is very similar in scope and size. It's called 409 Center Street. If we can move on, and then we'll come back to this building.
And yeah, if you want to start to make that change, I'll just explain. So because we're very preliminary in the design process for this one, right? Like this is what we have, which is very early. Andreas and I thought it would be very beneficial to show you one that's going to be very similar, so you see what we're aiming for in the space that what we can probably anticipate the inside of this one will look like generally, because these are sort of the directions and the standards we've given to our architects that are working on this other one we have, and will be very similar to what we give to the architects we're working on this one. See, Bryn has a question.
Yeah, thanks, both Meaghan and Andreas. I wondered if you could speak to the timing of this and, coming to sort of an ideas forum like this so early in the project. Does that add value, or how do you view that?
Do you want me to take this one, Andreas?
Sure, yeah, timing.
Oh, and then you can jump in. For us, so this is actually, yes, we think so. So this is something I've actually spoken to a couple of people about with the Savings by Design program, is how early, like how far do you need to be for this to really provide the value that's needed and really have an opportunity. So what we're really excited about is for previous ones, we've actually done it too early. So we haven't even had an architect on board. So this one is the first time we've been able to do this, because once again, we're fairly new in what we're doing. I know some other region, like I know there are other regions, even our architects on this have said to us, oh, we're used to doing this way later in the process. But we said, you know what, this is a really good opportunity for us to start to test some things that will really impact where we go and our design principles. Right now, we have some key design principles. We have a project charter that sort of says some of our main focus for this building is that there are family units. Like that's a really important thing for us because we are going to, that existing building is going to be operated as a daycare. So because we're putting a daycare there, because we have a lack of purpose-built family rental units in the community, like in the region, we want family units, like at least 30% of it has to be 3 beds. We want something that, as Andrea said, on the site provides what we need to connect in. So we've given those key parameters, but I think this workshop at this time is a really good opportunity for us to take as many ideas as possible, make a really good decision about where we go from here. Um, and then instead of getting too far down the design in concept or schematic design and then changing course.
Right. I think if we have, I think the timing's good just because there's a working massing and there isn't much wrong with it except for maybe the way the parking's working out. But the general sense, the general goals of having 52 units, 50 some units with this sort of breakdown, 1, 2, and 3 bedrooms, with the majority of them being in the 2 and the 3 sizes is super key. This is kind of what we're looking for. And in terms of the wall assembly itself, we know that we want a brick wall, and we know that we want at least those R values to start with, and everything else that comes out of this workshop in terms of what we can add to make it better is just bonus. Benji?
Yeah. Yeah. So is there any mechanical or electrical systems which has been designed or defined in this early case study? Or other than the envelope side?
Nothing.
Okay.
So what we, if you have air source heat pumps, well, let me take a step back. There are targets that we are going to be aiming for, and these are in the Durham standards. Like, for example, one of them is the SB10 improvements. So SB10 OBC has the amount of wall types, the best type of wall type that's in there. Let's improve it by 50% is sort of like the general sense that we're aiming for.
Gotcha.
There's other stuff like if it's a passive house, or if it hits your Teddy and Tewi at certain kilowatts per month. And there's a bunch of options that the Durham standard sets that we're aiming at. I think we're going over these this afternoon.
Perfect. Thank you.
Melanie?
Yeah, I was just wondering, when it comes to deciding how many bedrooms per unit, is there like, what's your criteria to make those decisions?
Meaghan, do you want to try this one?
Andreas can give you that.
Sure.
Yeah.
The main focus was what Meaghan was alluding to before, is that this will be a family-oriented type of building. So we're hitting 16 to 26. We're finding that in our existing portfolio, there's the 2 and the 3 bedrooms, and sometimes the 4, but mainly the 2 and the 3 bedrooms are the most wanted units, and therefore our mandate has been to increase that number as much as possible. And because we're mixing them in, in the sense that we're still going to be providing one bedroom. So if you have a resident that is in either the young or the old sort of spectrum, then they can go in here, no problem.
And I should clarify, Melanie, like we are responsible for the social housing wait list as well. So this is very helpful information for us because we can see right now in Durham region, there are over 11,000 people waiting for housing. Like our wait list is 11,000 households.
Yeah,
So we were.
Oh, sorry. I was just wondering if there was reasoning to have the one bedrooms versus just go to 2 and 3 bedrooms. Like, yeah, I was just wondering how do you decide that?
Yeah, so we kind of have a bit of a formula we put in. We do try to have a mix in every building. And but we definitely looked at this one and said, okay, we're going to have some one beds because we do know that we want that mixed demographic, but we're going to reduce it we also have another project that Andreas is about to show you that is fully one bedroom units. So we also know that we've already delivered a bunch of those as well. So we're just trying to balance it out with every project. I also see that Barbara has her hand up. Just while Andreas is switching over. Barbara, are you good to speak?
So I do know that Barbara put the question into the chat, and the question was, are we tied to the current layout, or is suggesting a change beyond balconies and things like that, beyond the scope of what you might be getting from the students? Remember that you're going to get 2 sets of recommendations. On Thursday, you're going to get recommendations from the Savings by Design team of independent experts. And on Friday, you'll be getting recommendations from these crack student groups. So let us know if suggesting a change beyond just balconies and maybe to the shape of the building, that's okay with you guys?
This is why we're doing this so early, and this is why we were so excited to be part of this, this is such a great opportunity for us to get a ton of different ideas at this time. So we are open to scope outside of just that. What we will say, and what I'll preface this with is, and sort of challenge the students to remember, is we have a couple things. One is you're going to get this presentation on the Durham Standard this afternoon, which really does provide some key sort of elements that we have to meet. Additionally, I don't know how much experience, but this is also affordable housing. And so in our case, yes, we're a government that's going to build it, but we are going to be applying to government funding, and we are building it. It has to be cost effective as well, right? And so just knowing that, like, for example, Andreas and I were talking about this. So my history just is I actually worked for Habitat for Humanity for over 20 years, building affordable housing there. So on the ownership side, Andreas, as an architect, worked in the private sector, but also worked for TC, Toronto Community Housing Corporation, building affordable housing there. And the thing with affordable housing is complexity always adds cost. So what we're always trying to balance is how do you have something that's visually appealing, that meets the needs, but also doesn't have too much additional cost, so that you stop being able to operate or own it as affordable housing.
All right, thank you. Can you hear me now?
Oh, and we can hear you now.
Yes, yay.
Yay. Andreas, do you want to show them 409 Center Street?
Yes. So 409 Center is just downtown Whitby. There's currently a 2-story building. I'll just do a quick walkthrough. But there's a old courthouse from the 1800s right across of it. But there's this 2-story building that it's basically from the 70s. It doesn't have heating and cooling properly. Well, it doesn't have any cooling. It's got a lot of problems with bugs and construction itself. and it's come to its end of life. We'll leave it at that. But what we're doing is we're doing this. We're doing a 3-story building. We're bringing in the heritage concept, well, the heritage requirements of brick that's there, that's in the neighborhood. We're hitting all the green standards. I'm just going to skip through this because we're hitting all the green standards requirements through the wall type assembly. And sorry if you guys are getting dizzy. I'll jump straight to the side plan and elevation. So this is the view from Ontario Street, north-south orientation. That's a side entrance. That was the existing parking lot, which has now been extended and doubled. That's the main entrance view with a glass elevated canopy at the back, elevated tower structure. That's the view from the front, and that's that Centennial Courthouse building right across from it. So it fits in context as a historical heritage site. So what we're doing in terms of green energy efficiency, and we're also looking at the social aspects of these buildings, right? So that you have amenity spaces that are connected to outdoor amenity spaces, parking lots that have depressed curbs, proper, new, barrier-free accessible. We have lobbies that maintain, that have enclosed spaces so that you have proper air that doesn't leak from the building like other buildings, like the older ones does. There isn't a proper lobby space, vestibule space. We have washers and dryers. Every single one of these units is barrier-free accessible. There's 30 of them, and we're meeting all of the higher standards of CMHC requirements, which are 20% of the building, and the turning radiuses are much larger than your standard Ontario building code. Mechanical spaces has been pushed to the basement, but I'll just go through one unit really quickly. You'll get a sense of how we're hitting, for example, this unit here, linear kitchen, 1 bed, and your living space. But you can see your standard turning radiuses are so. And we're introducing rolling showers, water closets that have all of the accessibility requirements. While the bigger 1-bedroom barrier-free will have a turning radius in front and on the side of the bed with a larger turning radius in the washroom as well. So those sort of things are the type of items that we're putting in. We're also putting a green roof in here to keep the area cool in the amenity space. And we're in the process of introducing solar panels on this roof. So I'll skip through these. Let's just reflect the ceiling plan. But yeah, this is kind of the look now. The new design, 3-story, front and back entrance, side views, and section. In terms of wall type, if anybody is interested, and the way the mechanical is working, we're doing air source heat pump for every single unit. It's a decentralized system, so it lowers the cost for us, and it also gives every single tenant their own freedom to set their temperatures, which is something that we were really keeping that in mind, because this is a 30-unit residences that are our senior citizens. That's our target audience for this building. So we're pushing for comfort as well as their own independence. And just in terms of construction, we're also putting in the larger R values are slated for in here. But I see there's a hand up, Danielle.
Yeah. I'm gonna ask specifically about the mechanical systems. For the townline project, are you tied to any specific system, or are we able to suggest anything?
You can suggest anything at this moment. Like
Oh, sorry, go ahead.
Our budget again is not, is not it's not the biggest budget, but it's fair enough that we could push for everything right now.
And just so you know, Danielle, so for example, we have another project that we're not showing you right now that Andreas and I are both working on, where we're actually pursuing geothermal for that particular project. So decarbonization, and you'll hear this when you get the Durham standard presentation, but decarbonization is a really important part of what we do. Secondly, because we are going to continue to be the owners and operators of these buildings for their life cycle, the reduced life cycle costs that you can get from a geothermal system once you take it over the entire life makes such a difference for us. So that's all factored into our costs, if that helps.
It definitely does. Oh, thank you.
Yeah, ideally for back on town line, like I would love to see some sort of geothermal field, either where 1 is or where 2 is, depending on what is a better building orientation.
So I think at this point, Bettina and Diana, like that's sort of an overview of the building. We really wanted to give this an opportunity for everyone to just ask a bunch of questions. Perfect. Okay. Does that work? I just wanted to make sure.
Yep, that is fantastic. So I encourage students, take a look, don't hesitate to ask the pages to come back up and have some questions. We've already had some great questions. I'm curious about your wall assemblies. Have you had anything that you started with? I see you have R values, but do you have, somebody in the chat was asking about rammed earth. Have you, I'm guessing at this point it's rather conventional, your initial design?
It is. I mean, yeah, if we were to do rammed earth, I don't know if that's a conventional approach. I have worked on rammed earth projects before, by the way. So in Morocco, out of all places. So I am very aware of how that works. Maybe in the foundation and the way the parking structure works, but most likely not. I think what we're really pushing for in Town 9 is as fast as possible. So because we have a deficit in our entire stock, and we also have just a deficit in Canada to begin with, and so as fast as possible in the sense that we're looking at modular pieces, modular wall assemblies, that type of technology.
I see David has a question, but just before, so right, for example, at Town Line Road, sorry, not Town Line Road, 49 Center, that is being built using CLT mass timber. So, and this one currently being under 5 stories, I know we have talked about it being a wood framed building and being able to leverage that as well, but the CLT portion as well, and panelizing.
I know you guys were talking about looking into the effects that balconies would have on the facade. In this spot of the project, do you guys have any idea of what the facade currently looks like? Have you guys looked at any like window to wall ratios or anything like that?
Good question. The window to wall ratio would be, I think it's a 30-70 split. what the
Okay.
green standard suggests. But we know we don't have any elevations right now. We only have um, just those floor plans. It's a box. Obviously, every single bedroom will have a window, but we
Mhm.
don't have a say, or we don't have an idea, a solid idea as to what's going to be.
Okay, and so you're kind of open to suggestions for the
Absolutely.
facade and the
Yeah.
assembly. Okay.
And what's nice about this one, so the one we showed you on Center Street was in a heritage district. And so Andres did a good job of showing you the courthouse across the road. So the building that we're replacing is not a heritage building, but it is in the district. So we had to conform to the district's heritage guidelines. And so in that case, that really forced us to incorporate brick. What's interesting is we literally just had a call last week with our architects talking about how for all of a sudden brick is actually a competitive cost right now with the tariffs. Aluminum, which a lot of people might have gone with as a cheaper alternative, is right now actually more expensive. So we are looking. So for example, with brick, that's like Andre says, we want brick, and that's mainly because we want a really durable material. But what I'd recommend is, as you guys are doing this project, make sure you go to Google Earth and look at the surrounding area and see where this is located, because that's such a key part. One thing I'll add is with affordable housing, one of the big challenges you always face is you don't want it to look like a box that has no personality. You need it to be affordable, but you can't look like a no personality box. And the likelihood that you're going to face opposition to your development is high to start with. So making sure that you've looked into the neighborhood and that you are planning to build something that will fit in well and that will reflect what is already existing is really important from the beginning, because you like you're likely going to at least have some opposition or some concern. So the biggest thing you can do is let neighbors know, oh, okay, well, we've actually looked at what you have, and we've noticed, and our building is going to fit in very well. So
Will
Okay,
the
thank you.
residents be people from the local community? Is that generally? Yeah.
I might ask.
I have a question. Yeah, sorry, go ahead.
This is your time. I'm totally jumping in on you guys' time, so go ahead.
Okay, thank you. I just want to make sure we're using air source heat pump for each unit to provide space heating and cooling, right?
Not necessarily. We could. We could use a combination of air source heat pump, electric boilers, and like rooftop units. Air source heat pump tends to always have some type of backup, especially for bigger units. Is what we're finding, is what we've seen. But by all means, it's a discussion. It's an open discussion.
Okay, and what about domestic hot water? Where do we get this water from?
Boilers, I would say, electric boilers.
Okay. A second question, if we are up to install solar panels, what is the available rooftop area for installing solar panels?
A rule of thumb is usually 3/4 of the space of the rooftop, just so that you leave 1/4 for rooftop units. That's my rule of thumb, by the way.
All right, yeah. So much, yeah.
and I think like the project that we showed you on Center Street, we actually had a pitched roof, but right now we are generally envisioning a flat roof for this particular project. So we're not against a pitched roof, but the part of the reason why 409 Center Street had that pitched roof was once again that heritage component, whereas here there's more flexibility that way.
I have
I'm
another
just.
question.
Oh, go for it.
Okay. The project is right beside Terry Fox Park, right?
Correct.
Are you guys open to suggestions on how you can connect the building to the park through concepts? Okay.
Yes.
All right. Were you guys exploring any like design options that would connect the building to the Terry Fox Park already, or?
Yeah, so the original design was looking at finding, so this was the 4-story building along the south of Blur, and we were actually figuring out how to connect it, like if we introduce a parking, like a landscaped area in front of the existing building, and then figuring out how to connect it through here, or utilize the parking that's here and maybe even extend it so that you have people driving in through here and parking and then utilizing Terry Fox, as well as having pedestrian connection so people could walk up through like that. It's not necessarily a building connection, but more of a pedestrian connection.
Okay.
I see that Krishna, you have a question, and then I know there's a question in the chat we're going to talk about as well in a second.
I was actually just about to mention that. It's the question in the chat where someone's having tech issues. So the question is, if you're considering a specific cooling system strategy, passive versus mechanical, and central versus local systems.
Well, passive in the sense that the building orientation would benefit. So if we can, if there's an argument that one is better than two or vice versa, then we will definitely go with that, right? So if we find out through this workshop that two is better, for example, the south is here. So all of these units have this amazing light, and however, because north is here, you know that there's going to be east-west light for this sort of linear building, right? So which is better for the massing and the heat massing of the building versus one or two? That's the passive answer. But in terms of it having mechanical units, yes, we need these mechanical units. We're not going to go full out passive housing, just because it's a safety thing. You know, if there's power outages for 4 or 5 days, we need to have a specific spot the residents can come down to and then stay in there, especially in winter.
I just realized one thing we should clarify is right now we're targeting 52 units on this site. So that's sort of what we're looking at. And so the one building has about 52 units in it. We always have a bit of flexibility there, but that's sort of our target as well. And so that's a fair number of residents that we're introducing onto this site, which also impacts some of those decisions that we have to think about, like long-term safety. And well, we always have to think about, but in terms of, you know, the building and the systems that we put in.
There's another question. I apologize. The rammed earth question was asking about whether or not rammed earth had been considered between units. And I'm curious as well about between units given noise transfer, odor transfer, those types of things. Have you considered, as well as flexibility in units, the possibility of perhaps taking a 1 and a 2 and making them a 3 if you need it, and then turning it back into a 1 and a 2?
Not yet. That's a really interesting question. I would love to do that. That's just sort of my take on it. Like, for example, if we were to take this and turn it into 2-bedroom, the building footprint is small enough that would be possible, just because we don't need any sort of fire separation from other buildings or from within itself. So that's a possibility. It would depend on how this is all stacked, right? If where the bathrooms are, how the units are laid out. But at the moment, what we are considering is a centralized system, just because we're doing a centralized system seems to have a better response time, and we will probably introduce BAS in here as well, just because of the size and scale, and it's at that threshold over 50 or so that you want to have more of an automated system, right? But yeah, if we could do that, that'd be great. Like if we could do the 2 bedrooms and get rid of this partition wall. In terms of noise mitigation, we're hitting the same standards as per OBC. I think it's a 55 STC, if I recall correctly, at the hallways, and I don't recall what's in between units. But that could also be mitigated.
Sorry, could you say those values again? My audio
Yeah,
got chopped up.
no problem. I think it's 55 STC as per OBC, but don't quote me on that. I don't remember it off my head.
One thing I should add too is that in terms of height of the building, we're maxed out at the 5 stories because we don't want to have to go for an official plan amendment. So right now, within the current zoning and official OP, 5 stories is sort of the maximum. So just so in case someone's wondering, that kind of is why we've landed there. And I see there's some parking questions. I'm going to take a stab at them because this has been quite. One of the challenges of this site is that because we have the daycare and there will actually also be administrative space in there, so right now we're providing about 44 parking spaces for this building. But what we're having to figure out is how that works with all the parking that's required for the institutional use that's going to take place. And so this has created quite a lot of complexity on this site, because right now they're estimating they need about 90 parking spots, which is a lot. And so we're trying to figure out where's the best place to fit housing. Right now, this design, if you can go back one for a second, Andreas, this design only provides sorry, no, just one slide or view.
Yep.
Yeah, perfect. So right now with the 1 level of underground parking, we have 44 spots. So you've got, I think it's 30 in the underground parking, and then you have 14 surface level spots. That's not a 1-to-1 ratio. And right now in all our buildings, we are trying to at least target a 1-to-1 for parking, which includes visitor. So we are trying to, like, this is on a major transit route. At least Bloor Street is there is Durham Region Transportation that goes along there, but because it is a little bit where it is in the city of Oshawa is it's right on the outskirts. So there is amenities nearby, but this isn't like it's right downtown Oshawa or right on the core, right near the core of downtown. So we're trying to balance that out. And you're right, the accessible parking right now is all in the surface level. It's not in the underground at this moment.
Maybe this is kind of like a good time for the question that I was wondering about, because it feeds into whether people are getting the signals from the site about parking or driving or walking. So I was wondering, when you think about the main entrance that pedestrian might see, do you anticipate that to be street facing, or do you expect it to all be inward and like amongst the parking?
That's a great question.
I would say that it's their first sort of stab at it. What LGA came up with, which is south facing, is a good sort of entrance for the building itself. So what they did is they connected this sort of walkway here, and they created this entrance as a pedestrian entrance, while they're having a moving entrance here off of the core. So the vestibule is here, and the vestibule is like that on the main plan. So this kind of connects you to Terry Fox that way, and then the pedestrian entrance connects you to Town Line and Florida. So if it's situated this way, that would probably flip that change altogether. But it's kind of finding a balance between this being a car-friendly building and a pedestrian-oriented building. Like Meaghan was saying, it's not really a pedestrian-led or pedestrian neighborhood per se, but because we have Terry Fox right there, it's like we have to take advantage of it.
I don't know the answer to where the closest public transit spot is, so I'm going to try to find that and send it over to Diana, but right now I can't find it. So stay tuned.
Yes, thank you so much, Meaghan and Andres. Thank you. We greatly appreciate you taking this time to talk about the building with all of our students and answering everyone's questions. Now we're going to move into our coffee break chat time. If Bettina would like to introduce our guest, who you are free to, of course, get up, go to the bathroom, get water, get coffee, or you can stay on the line and get to speak to our guest. Bettina?
Okay, and this is a crucial part of boot camp. This is the absolute informal. You guys already kind of did it with Alex, which I loved. And that is that we have speakers who sometimes will stay after their session so you can ask them more questions. Or in this case, we have my fellow board member, Sebastián Carrizo, who's here. He just loves boot camp as much as we do. And Seb has a great story about how he got into this industry, and I've asked him to come and share it with you, but this is completely informal. So literally grab a coffee, sit back, relax. You don't have to sit for this. You can stretch and do whatever you want, but we're gonna throw it over to Seb to have our first coffee chat. This will be every morning. We'll do these.
Hi, everyone. Thank you, Bettina, for inviting me. Yes, my name is Sebastián Carrizo. I go by Seba for short. I'll tell you how I got to sustainability, but really I'm hoping we can just talk about whatever is in your mind or whatever questions you have. I'm an associate at Dialogue. It's an architecture firm, and I specialize in energy performance and simulation. I've been in this field for roughly 12 years, I think, which makes me really old. And I come from Argentina. So just quick, just generally how I got here. Born and raised in Argentina, didn't do sustainability or mechanical engineering or architecture as a background. Actually, when I graduated, I worked for Unilever and basically was predicting how many bottles of mayo they would sell. And basically that's how they would stock their warehouse. Met who's now my wife traveling, came to Canada, and the easiest way to come was to get to do a master's program. Applied for one in sustainability at Carleton University, always thinking I would go back and it would be just something fun to have and say, hey, I have a sustainability background. Throughout that year and a half, I found buildings and I fell in love with the puzzle that buildings are and design, and finding that intersection between people, design, technical background, and just generally simulation in general. And then decided to stay in Canada and build a career around it. I love stories. I love telling stories. And I think design has a story. And I think uh, people should be at the center of what we do, both from who we design for, but also how we design. So talking to architects is very different than talking to engineers, than very different than talking to developers, than very different than talking to users and occupants. So really my job these days is to be kind of a translator or storyteller in a way, and turning kind of complex things like energy models and simulations into actionable guidelines. And at the end of the day, we're trying to build a better building for people. So that's a little bit about me. I have 3 kids. I have a dog. I live on the East End in Toronto. I enjoy camping and played curling for a while, actually. So that's just me in a nutshell. I don't know if anyone has any thoughts, comments, questions about just generally the industry, but I'm happy to open the floor up, I guess.
Sebastian, if you were to take your skill set here in Canada that you're using every day back to Argentina, would you have to substantially change your approach?
Oh, great question. I think it would be to be adjusted. Particularly looking at Southern Hemisphere, things are kind of upside down. So when you're facing solar panels, you don't optimize to the south, you optimize to the north. Um, Weather is slightly different. We don't have as cold winters, and as a result, just building codes in general are different. Uh, I don't think the process itself would need to change. I think what we're seeing in this industry is that it's about kind of building that connection and that process through the design practice, which would still be applicable in Argentina. I'd say it would be hard for me to speak in Spanish in a technical sense, but no, I think secretly that's always been kind of one of my like passions is how can we bring this back to where I'm from and where I grew up. Reality is back home and particularly in a lot of kind of developing countries, sustainability, although very important, is not, I'd say, as top of mind as other challenges that we have there. So the hope is that we get there and that we're able to kind of take some of the lessons that we're privileged here to learn and take them back. So yes, no, maybe was the answer. Yes, Danielle. Right. Yeah, I thought it was super interesting that you're from Argentina. I'm from Brazil. Well, there you go. Yeah. Yeah, I'm currently doing my master's in building engineering at Carleton. And you mentioned that you work with the building simulation. Yes. And I wanted to know like which tools you usually use and if it's just energy, like whole building energy, or if there's any simulation tool that you also use for, let's say, airflow or air quality, RUQ. That's a great question. I'll say there's way too many tools, which is a good thing, but also kind of overwhelming, particularly as someone who's coming into the field. I'd say the tools, particularly on whole building simulation, which is, I'd say, 90% of what we do. The tools that are used in academia aren't necessarily the ones that we're seeing in the practitioner side. So that's something to be mindful of. I'd say things we use on a database is at least at Dialog, we use IS, generally speaking, as the tool, and we see that one of the top 3 tools that we use in the industry. It's not free. I think they've come a long ways in terms of access to students. The other one for a long time was eQuest. I think now we're seeing a lot more Open Studio, Energy Plus as I'd say the 3 kind of big ones that you use. The good news about kind of any tool, to be honest, once you understand how it works and once your brain is kind of set up in like understanding the process, picking up new tools is not that hard. And I'd say that should not be kind of something that keeps you up at night in terms of, oh, I don't have the right tools. Most of it you learn by using the tools, to be honest. And generally speaking, the tools that I'm talking about are on the part 3, so the bigger buildings, let's say. There's a great question on the chat around HOT 2000. Yes, HOT 2000 is a tool that is used particularly on Part 9 buildings. A lot of the work that I do these days is not on Part 9, so it's not on small residential. It's anything that's like 3 stories and above on the residential side, healthcare, so hospitals, higher education, wellness, all that stuff. So in general, so you are at Carleton. Talk to Liam O'Brien. He was the kind of the one that got me into green building design and sustainability. He now has a great team of people there. So if you're particularly interested on the modeling and simulation side of things, reach out to him, reach out to Barack, and just get involved and see what it's like. And I'd say that's the key of my learnings, to be honest, between academia and the practitioner side is try it. Spend a little bit of time modeling things in the quote unquote real world just to see if it's something you like. Because to me, at least, I need to like what I do and I need to be passionate about what I do. And energy modeling just happens to click that box for me. But I wouldn't have known it if I hadn't tried. Let's see what else. I have a question. Would you say that sustainability, as discussed in Canadian architecture, is approaching a matter that can be implemented effectively in the global sense? My family is from Nigeria, and sustainability is not always the main priority in architecture due to other critical issues in urban infrastructure. How may we integrate Western ideas within the needs of less centralized developed regions? That's an amazing question. Honestly, that's something that as I've spent most of my professional life in Canada, is something that's always in my mind is how can I bring this back? Particularly for me, it's where I came from, which is South America. There are similarities in terms of some of the struggles and the challenges that developing countries have. I don't think there's one way to do it. And I think the key is for people like us who are in a position to be able to learn from here is to take the time to go back and even if it's just have these conversations with practitioners there, just try to get involved. I'm very wary about bringing kind of, let's call it Western or like North American practices back home because oftentimes there's different challenges associated to it. I think we are great conduits to be able to filter that through the lens of our experiences and our growth, and taking the opportunity to go back. So I'm privileged enough to go back to Argentina quite often. And one of the things that I do back there is I'll go back to the university I graduated from and I'll give talks about this topic in the context of these are things that are happening somewhere else. And I find that going back and doing that is a way to kind of start that conversation. Let's see. Liam's last name is O'Brien. So his actual name is William, but he goes by Liam. So yeah, Liam O'Brien. Perfect. I really like the language you use with your answer. Thank you so much. Oh, anytime. And I think honestly, as we think about how we get involved in bringing things back, I think we always have to be careful about the cultural element and how some of these techniques or some of these approaches kind of will vary country to country and region to region. Going back to Bryn's question, I think that the process and the thinking will be the same. It's just how do we bring in the local context that really is what's going to make it or break it in terms of implementing some of these things. I've noticed that many people in energy modeling come from an engineering background. Do you have any advice for someone like me coming from a non-engineering background on how you build credibility and add value in this field? That's an awesome question. And honestly, there's this, not myth, but there's a reality that most of the modeling, at least the people that do energy modeling, do come from a more mechanical engineering background. I have the great story about our team has the best modelers that I've worked with are not engineering backgrounds. In fact, one of them, her background is in music, and she then went and did a master's in building sciences, but her background is in the French horn and music. I'll say what you think right now is a disadvantage of not having an engineering background is actually a secret ability that you should hold on to. What we're seeing is as we start interacting, as we start using energy models to tell stories and to engage with other disciplines, we need that mixed variety of backgrounds and particularly exposure to different things. And our team has a collection of architects, people from the business side, engineers, music, as I said, my background on sales, I guess, and predicting warehouse stock. So it's an exciting field because it's open to all backgrounds and everybody brings something different. I've worked with great people who in the sustainability world are from the planning background, master planning at that scale, and being able to kind of zoom into a building and zoom out is really important. So really the credibility, you build it on a day-to-day and working with people and building trust and relationships. So it takes time, it takes effort, but there's no going to be a limitation because you don't have an engineering background. If anything, as you progress in your career, you'll find more and more that that is actually something that makes you unique and different to everyone else. I skipped between my conversation how I got here, that for a year and a half I was unemployed, having an engineering background and a master's degree from Canada, as most. As I shouldn't say most, but as some immigrants to Canada, it's very hard to get that first job. So for a while, I did construction on the side. I bought and sold containers of used clothing because I knew Spanish and that was a big market. All those things got me to where I am. So there's no. The one thing I'll say, and I'll tell everyone every time I talk, is I kind of got here by not by luck, but a bit, yes, like by kind of chance. And I grew up not knowing what I wanted to do. I mean, I wanted to be a soccer player, but that eventually, when I was 12 or 13, it was very obvious that that was not going to be the path for me. But I always struggle with this idea that I would see people come in and present, and they knew since they were very little that they wanted to be architects, and they had done all these paths and had all these courses, and then they took an architecture degree. And I found myself as a university student not really finding my path until I got to finishing 2 degrees and getting into an industry I didn't know in a country that was not my own. So you don't have to know everything. Like, it's great if you know exactly where you want to be. That's awesome. That's not necessarily a path for everyone. And for me, it's actually been going around and trying different things has led me to where I am and gives me a little bit more exposure to other things that I would have not necessarily been to. So in general, try things, get to be on a day-to-day of whatever it is you're trying, and you don't have to have a plan. Right. Like every year things change, and what I did 5 years ago is not what I'm doing now. My balance on a year-to-year basis, I look back and I say, did I do more things that make me happy or less things that make me happy? And then just try to steer that towards what I liked and that happiness, just because that changes as well. I have 3 kids now. My priorities now perhaps are different than they were 6 years ago. So you don't need to have a plan. It's great if you do. If you don't worry about it. Just go through the process and find the right people and connect with the right groups, and try things. Let's see, are there any other questions? There was an earlier question you may have missed. I'm pursuing a master's in building science. I'm very interested in energy modeling. What suggestions do you have for me to build a career in this field? Great question. Find groups of people. I'd say find those communities of people that are in the sustainability world. Toronto, Ottawa, Vancouver, every big city, major city in Canada has those pockets, and oftentimes about finding and clicking those. So Sustainable Buildings Canada is a great place to start. ASHRAE and the CAGBC. If you're in Toronto, there's something called Green Drinks. If you want the more technical side of things, there's the International Building Performance Simulation Association, shortened to IBIPSA, that they host events. Really find those social events and find those people and connect with the people. And once you find that person, poke them and say, hey, I want to be more involved here. Can you put me in contact with some other people? Share, like, I came in without having a lot, like, moving away from academia. The mentorship is really important in our field, and it's something that we oftentimes not take for granted, but as you get kind of more into your senior roles, you forget that when you were starting, you would have really helped and valued having that person. So find those people that you connect with and that you share values, poke them in LinkedIn and say, hey, I saw your profile. I know you guys do cool work. I'm new in this industry. Can we just go out for coffee? Which, by the way, that's how I got my first quote unquote sustainability job, was just to go out and talk and have coffees with people. So connect with people, find things that resonate with you from where they are, and let them tell the story. Most people like to talk. You can see I enjoy talking about myself and things that we do. So just leverage that and find those people and yeah, ask them, hey, help me get involved, help me get into this industry. It is about people, by the way. Let me see. I just want to ask some tips on how to make a good presentation about energy modeling. Oh, that's a great question. And that's one it's taken me, there's no perfect recipe. I think the first step is take a step back and think about the audience. Think about who you're telling. Like, it's a story. So a presentation, I will tie it to a story, and stories have a beginning, a middle, and an end, but they also have an audience. And it's not the same to tell the same story to kids as it is to adults, as it is to engineers, as it is to architects, as it is to developers. So really take a step back and think about who you're talking to and what their values are, and then craft your modeling story, and particularly the level of detail you go into, to make sure that they're understanding what's being explained, but also that there's an actionable item. Like, work towards a yes or no, a let's do this or let's do that. Open-ended stories are oftentimes hard because there's no follow-through. So what I do these days is I'll come up with a presentation and I'll try it on my 8-year-old. And I'll talk to my 8-year-old. And if I see that I lose him, then I know that I've gone a little too technical. If I see him asking questions and I know I've kind of hit, at the very least, from a jargon perspective or from an acronym perspective, the right note. And that's something that as an industry, we have way too many acronyms and we assume that everybody knows everything we're talking about. And half of the time we don't. So taking a step back and looking at your presentation from somebody else's perspective really helps. Finding people to bounce off presentations. I don't always use my kids, by the way. Sometimes I'll use colleagues and other peers, but just take the time to go through your presentation with somebody else in their mind and make it as visual as possible. Architects and graphic designers are great at visualizing things and making sure you have the right amount of white space in things, but we tend to cram too much, particularly as an engineer. So having other people look at it is always at least for me, it's helped. I'm just gonna go. So I know we have a few on the chat, but I like people telling me questions. So I'm gonna go for you, Farouk. Is it Farouk? Hopefully
Yes,
not
hi.
butcher that. Okay, hi.
Yeah, you got it correct. Yeah. Because I'm interested in the one thing because as people we are doing networking, and sometimes we go to these events to talk to other professionals, to get to know other professionals, because that's what I believe that's what the purpose of the network is. Maybe one day I might see you at a conference and maybe we will be connected. Is in the future, I believe, is there going to be a type of network for construction and engineering in which it's going to bond them to run businesses quickly?
Yes, I mean it's an interesting idea. That's not necessarily how the industry works right now, but it's definitely something that could be happening. To be honest, not sure. Um, as you said, like, networking is about people, and particularly in this field, it's about kind of younger people, to be honest, and that's something that's quite exciting. Um, about our industry is that it is kind of driven by kind of the latest knowledge trends tools. So I'd say yes, it could happen. I don't know what that looks like. As it currently, like, current networking is what you described as going to events, is putting a face to a person and having them kind of recognize you and building that relationship. I found I'm not that good at networking when there's no passion and when there's no kind of personal element particularly. So the way I tend to do most of quote unquote my networking is through more social events. So I tend to gravitate towards, yes, there's conferences that are really great from a technical perspective. I enjoy more the social networking, to be honest, and getting to hear people's thoughts and opinions on topics. So that would be something interesting to see, is more networking. Like maybe it is an event where there's a panel and there's a conversation, but less on the technical side.
So more on the less on the detailed hard work, and more on the having communication, talking.
Correct. And building connections to people, and getting to know who you are beyond just all the things that you do. It's something to think about is when somebody asks you like, oh, when you have to introduce yourself, do you start with the what you do, or do you start with the who you are, or how do you introduce yourself? Really tells a little bit of how we're kind of wired to network. And oftentimes it becomes with, hi, this is my name, this is what I do. And I think that that's something that if you can start thinking about it in terms of, okay, well, I'm more than just what I do, you'll start finding a lot more meaningful connections and networking at that personal level. So it's something I'm quite aware of, and I always fall into it. Like I started by saying what I do, just for context, but I think there's a way of networking that is less about what we do and the things we develop, and more about who we are and what our values are and what do we bring to this conversation.
Amazing. Thank you, Sebas. And for those of you who haven't, very few of you haven't, but we have a LinkedIn group. I've just invited Sebastian and Bryn, and our team is on there as well. LinkedIn is very much a part of our industry, and it is an excellent way to connect. I love your recommendation. I get asked all the time for informational interviews. Happy to do them. We're all, Seba says the right things. Like everybody's happy to talk about themselves for a couple of minutes, but you get ideas and you get things. There are mentorship programs out there. Obi, I will make sure that you get invited to the LinkedIn group. Well, I think Daniel's going to put it into the chat. And so speaking of connections, the next part is for you to meet your team. So round of applause to Sebastian. Thank you so much. And you're coming back another day, is that correct? Awesome. So if you have questions for Seb, he'll be back.
Thank you for having me. Bye, Ron.
Bye. Okay, so this is one of our most favorite parts of the group of the week, is that you get to meet your team right now. Hopefully everybody's online. We do have a big number of you. If you're able to turn on your camera now would be the time. That would be very helpful so that we can confirm, because we've set out groups. And thank you. I really deeply appreciate it. I know, and you can blur your background, do whatever you need. Yeah, put on. Oh, hello, everybody. It's so nice to see you. Fantastic. Okay, so what we've done is we've put you into teams. They are cross-institution, so hopefully you won't be with anybody that's in your university or college, but if you are, you're probably studying in different fields, so you will definitely be meeting somebody new, which is very exciting. And also, so not only cross-institutional, but also cross-curricular. So there will be lots of variety of expertise and knowledge in your group. And the idea is your group will be representing what happens in the integrated design process. And that is, you have a lot of people. We saw it today in the session with Meaghan and Andreas. We saw that people were asking really interesting questions that maybe you hadn't thought about. And that happens all the time. And the great thing is not to be afraid to say, hey, while I was looking at this, something occurred to me. I had a question. There are no dumb questions. You are going to be working in the real world very, very, very soon. You're in academia where, you can challenge the professors, you can do whatever you want, but this is your introduction to the professional world and how things operate. And so when you're first starting out, it might be a little bit scary to ask a question. That's not the case here. Now is the time to just, ask all the silly questions that you have, like what is window to wall ratio? What does that mean? That's okay. Somebody will be able to answer that, but you might be able to answer a completely different question that has nothing, like Seb was saying, one of the best energy modelers they have is a music student. So remember that just because you don't have that professional background, that matters nothing. You might have the most open mind for making a suggestion for your group. Okay, so your groups, I'm going to put it into the chat. You've got until noon, and then you've got lunch.
So we will be putting you in breakout rooms, so you will get to meet each other. So we're going to open those now.
Wait, because I have to give the instructions.
Yes, Bettina's going to give you some instruction on the activities.
Okay, so you're going to, as you can see in the instructions, so for this very first session, I've assigned the leader is the person who lives the farthest from the project building. And that person's job is to get the conversation started, have people introduce themselves. I'd like you to make it both human and resume oriented. We're not just our school and our work experience. We also are, I will share with you the cats that are sitting in my living room right now, sofa. So, and we've got the whole team here as well. We're working out of my apartment this week. So something personal, something professional, something study. So your job is to introduce, to make sure that you guys get to know each other a little bit. And then you have 3 jobs. You have to decide a team name. We like funny and creative names. This is pretend you're at a pub quiz and you're trying to come up with something. But also remember, your team name will have to be presented when you do the recommendations to the group on Friday to Meaghan and her team. After you've figured out a time name, then you need to exchange information about how you can get in touch with each other. So there is team time every day. There's lunch, etc. But some groups do find that it is easier for them to meet a little bit later in the day. There's some people that are from out west, and so there are time differences. So you guys decide, make sure you have each other's contact information, your phone numbers, your emails, etc., and figure out what system you want to use to talk with each other if that's needed. And then start brainstorming some initial ideas. And there are no wrong ideas in brainstorming. What I want you to keep in mind is we're going to ask you for one recommendation, not a laundry list. On Thursday, Meaghan and her group are going to get recommendations from the experts, from our subject matter experts, like people like Alex, like Sebastian, etc. These are the experts that SPC hires to come and look at the projects and give them very specific advice about increasing the R value and this mechanical system and what have you. That will be our particular recommendations on that given day, given those particular experts. What we want to see is that your recommendation makes sense with the group that you have. So if you don't have a mechanical expert in your group, don't give us a mechanical recommendation. If you have really creative ideas, remember that this is the first time Meaghan and her team are ever designing or building a building, ever, for this Durham region. So there are no bad ideas. So think about what is a really important and unique and not necessarily, very professional in the sense of, what the experts would say, but more, what does your team feel as a whole is a really important element that your group might want to do. Okay, so just start brainstorming. That's it. And we're specifically giving you time through lunch. So Diana's going to put you into groups. We'll be back here at 12:30, where we're going to hear from the region of Durham. They're going to talk to you about the very, very high standards that this affordable housing unit needs to meet. So it's a really important next session. But in the meantime, you've got team time from now on. We'll leave the teams open. We'll be here in case you have any questions. You can always pop into the main room. But everything clear? Any questions before we throw you into the groups?
Okay, it is around close to it. Okay, now it is 12:30. So we have a new speaker for right now for this session. And today we have Paul Pasqualini. Did I pronounce that correct? I think I did. He is a professional. He has a professional engineer with a master's in applied science degree in building science. He is passionate about designing and constructing resilient and durable buildings that incorporate measures that are respectful of maintenance requirements and end-of-life replacements. And it shows with his 25 years of experience in high performance enclosure design, rehabilitation of exterior walls and roofing, and failure analysis and envelope components and systems. Sorry. So please join me in welcoming our fine speaker.
How's everybody? You guys can hear me well?
Yes, we can hear you.
Great. Thank you for welcoming me to partake in this boot camp. It was actually interesting to put together a presentation that caters to a variety of backgrounds and skill sets. So I hope you all find it interesting and take something away from it. It should be about 45 minutes. You're more than welcome to interrupt and ask questions as we go through. If not, we can deal with hopefully a lively discussion at the end of the presentation. So without further ado, I'll get started with, I gotta get rid of this screen, so I gotta get used to this platform. I apologize. Okay, so what's the main objectives? There's, I guess, three here. By the end of it, you should hopefully understand the different control layers that are built into exterior wall designs. And primarily what they're there for is durability and energy management. There are a lot more functions in an envelope, but we're going to focus on the ones that deal with really durability and thermal performance. You're also going to learn hopefully a bit about thermal bridging and its impacts on the whole performance of an envelope, whether it be from an energy standpoint and also condensation and mold growth. And realizing that you guys are looking at a building, so there's going to be some general discussions about features of buildings such as roofs, the walls, and other conditions like soffits and foundation walls, so above grade walls and below grade walls. As you may know, windows are not on the menu on this presentation. I think there's another whole presentation on that. Windows can certainly take a few days of discussion, as does Building Envelope 101. There's a lot to cover, and I've tried to make this as informative without being boring for those that have some background. So bear with me as I go through some of the basics and whatnot. But I've tried to keep it somewhat high level, given that we only have about 45 minutes. So what is a building envelope? There's lots of names in this industry. Building envelope is one that I started in the business with. Of late, people are calling it building enclosures. More or less, it's obviously the same thing. It's essentially the envelope that encompasses a living space. So from your slab down to your below grade walls and your above grade walls and your roofing, that is what you'd consider as your full envelope. So the building envelope consists of I guess a whole system of components which create this assembly. And the main purpose of the envelope is really to separate your interior from your exterior. And as I mentioned, in doing this, it has to control the transfer of moisture, both exterior moisture, such as rain and snow, and interior moisture, such as water vapors that you would generate, say, in winter conditions, either from cooking or showers, or you intentionally humidify just to keep the air with enough humidity so that you don't have static electricity issues or even dry skin. The other two important aspects of, say, control layers would be your air barrier and controlling air transfer through the envelope and heat transfer. if you Google what an envelope's supposed to do, there's probably about 12 or 15 things when you start to really look at it. When you look at fire or structural, but we're really, as I said, going to be focused on the durability aspects of it and energy performance. So someone has taken the time to really look at wall assemblies and try to categorize the different performance types or philosophies in their design. And here's a table or sort of a chart that summarizes what I've identified as what I would call the contemporary wall design. And it's called pressure moderated or pressure equalized walls. I mean, if you could think of an old church wall or old heritage masonry wall, those would be considered your mass walls. And then in the 60s, probably 50s, they came out with more framed walls, and then that is broken up. And when I say framed, you're talking about timber or steel, as opposed to thicknesses of concrete and or masonry as being what you would consider a mass wall. The walls eventually got more complicated and I would say more complicated insofar as looking at different components and how to deal with energy, how to deal with moisture. And it's evolved to what people have, I think it was in the 60s that they identified, and it was a Canadian that identified the pressure equalized rain screen type concept, which I have here in a dashed box. Really, I would consider more a theoretical wall in terms of the pressure equalization. And the idea is that you're trying to minimize the amount of water that gets into your wall. So you create this sort of screen on the exterior and a cavity behind that to limit the amount of water that would get into, say, the main fabric of your wall where your insulation and your framing would be. As opposed to a mass wall where essentially you had this lump of either stone or concrete, and there was really no other layers within that assembly, and you relied on that assembly to sort of absorb the water and prevent the water from entering. Here we have a bunch of different guards, if you will, to address moisture from the exterior. So walls aren't really pressure equalized, as I mentioned. Very, very few walls can achieve that. So in the industry, we use this term pressure moderate because you never get full equalization. I'll elaborate a little bit more about what the equalization refers to. So as I said, you're minimizing the amount of water that can get into deeper parts of your wall assembly. So protect the wood or the steel from corrosion or wood rot in the case of, say, wood studs. So pressure moderated, this is sort of an idealized look at a wall assembly in section, if you will, exterior being on your left. So the idea of this pink is your rain screen. It's your either your brick veneer or your vinyl siding or metal panel. Behind that you have a void space, and that void space is your drainage cavity, and within that cavity is where you're dealing with a majority of the moisture that may penetrate your rain screen. The concept of pressure equalization or moderation is you're trying to actually achieve pressure within this, or air pressure within this cavity to equal the pressure on the outside of the wall screen. And if you have that sort of pressure balance, then you're not really drawing exterior moisture into your wall assembly. Thus, you're really minimizing the amount of water that's being drawn into your cavity. The reality is when you have a lot of rain and wind events, the wind is what actually draws or pushes much of the rain into or the water into your wall cavity. So again, getting that pressure equalization or moderation limits the amount of water that can get into this space. There's a whole, I guess, another discussion about how do you achieve this, and we're not going to get into it, but the concept is you essentially have this cavity and you have this drainage system behind your rain screen. And the other function is that you want to get drying. So drying is a really important aspect of any of these veneer walls, whether it be pressure moderated or simply a drain system. That is by far your largest and best way to dry out your wall assembly. It's actually getting air flowing behind your rain screen to pick up water vapor and allow it to evaporate and be carried to the exterior. So when you look at exterior wall design and you're trying to deal with moisture, the main thing that you want to do is deflect as much of the moisture as possible. You want to minimize how much you can get through. So having either a thick wall, a thick assembly, or an impervious assembly is really important from that perspective. So having deflection and overhangs and drip edges and whatnot are quite important. As I mentioned, this cavity is drained, so that will assist with essentially any water that does get through your deflection system. It'll allow it to then be guided out of your wall assembly. And as I mentioned, the drying and creating sort of ventilation behind and through your cladding system is really key to keeping your wall dry. I've already talked to why we have this term pressure moderated, so I won't go into that anymore. So your second control layer would be your to deal with interior moisture. And so again, this discussion is really about our colder climate and how you would be designing a wall for our conditions. So in the winter, you generally have a higher moisture level inside your living space, as I mentioned, through whatever cooking activity, shower activities, and people intentionally humidify. If that moisture were to get into your wall assembly through either vapor diffusion or air leakage, which I'll talk a little bit more about later, you can have a lot of issues within your wall assembly, again, either corrosion or mold generation. So we essentially install a vapor retarder or a vapor barrier. There's a key difference between the two in terms of how much that particular product that you use as a vapor, either retarder barrier, actually slows down the transfer of water vapor through your wall assembly. The mechanism, which I'm not going to get into a whole lot, is known as diffusion. So it's literally looking at water vapor molecules, and they migrate basically based on concentration. So if you're in your home and you have a higher concentration, which you would do in the wintertime, they automatically know that the exterior is a lot drier in the winter. There's a lot less moisture in the air, and there's this propensity to want to equilibrate vapor pressures, if you will, and those molecules will make their way through that wall assembly. So this vapor retarder is what's used to sort of slow down that process. So what do we typically see for vapor barriers? Polyethylene sheet is what you would typically see in low-rise type residential construction. It's essentially a semi-translucent plastic. You can also get into rubberized asphalt sheets, which are usually installed on the exterior of your wall assembly. I'll show you a couple of images of these. And it's a rubberized asphalt. It's quite thin, maybe about 40 mils thick, maybe millimeter and a half. And then there's other products that are either troweled on or sprayed on membranes. So on the left here would be a typical polyethylene sheet. You're looking up at a ceiling at the upper floor, and above that would be your attic. So all the joints are being taped to try to create, in this case, a vapor barrier, but also they're likely intending this to be an air barrier. You'll notice on the walls, they actually don't have a vapor barrier because they used a foam plastic insulation, which I'll speak to a little bit later, but it has some inherent vapor barrier qualities to it. So there's no need to put a vapor barrier in this type of construction, being what I would say is maybe a residential. Things would be a little bit different if you're more of a high humidity environment, like a museum or a swimming pool. Envelope would be, or the vapor retarding components, you'd be a little bit more robust and different. On the right here, you have what looks to be a membrane. I've sort of showed you here on a roll. It is, as I said, it's about 1.5 millimeters, and it's actually, in this case, a peel and stick. So it adheres itself to the sheathing board. This is a form of a vapor barrier. In this sort of scenario here, you would have your insulation, your insulation would all be exterior. So it would be placed on top of this blue membrane, because this barrier is quite a retarder to moisture. And if you did have insulation inboard, you possibly could have some condensation issues again. So I'd speak to that a little bit later. So this would actually function in the case of this wall assembly as a vapor barrier and an air barrier, which we'll talk about next control area. So air leakage is another, I would say, enemy of the wall assembly in terms of durability, but more so from, I would say, energy. So to deal with air movement from inside your home or your office space to the exterior, we install what's called an air barrier. Many times, an air barrier and a vapor retarder are one and the same, depending on the wall assembly. You try to get one product to function as both. I'll speak a little bit more about that later. And as I already alluded to, one of the main issues for air leakage control is really to control energy loss. So and I can't stress the importance of having an airtight building from an energy perspective. I mean, there's a lot of time and energy spent on looking at R values and insulation thicknesses and whatnot, but if you cannot have a way to control the air movement from inside the building to outside the building, for example, a door, you could imagine how much airflow would occur, and essentially that airflow, you'd be losing a lot of heated air, which obviously there was a lot of energy and cost associated with heating that air. So air exfiltration is by far, or can be by far, a lot more detrimental from an energy standpoint as compared to, say, just looking at R value of your wall assembly if you don't have a robust air barrier. The other issue is moisture damage. So I mentioned vapor retarder and diffusion of air vapor molecules from, say, your interior space to the exterior. That's a very slow process, extremely slow process. Air leakage, as you can imagine, if I use that example of opening the door during the winter, or a window, you'll have a lot of air flow through that opening very quickly. So as I mentioned about energy, so if you have this humidified air and you have sort of these breaches in your air barrier through your wall assembly, you're going to be leaking a lot of warm air, but that warm air is carrying a lot of moisture. And as it travels through the wall assembly, through the insulation, it'll cool down and you'll have resulting condensation, which could lead to mold, could lead to corrosion, could lead to rot. Again, it depends on the wall configuration and where your various components are, but it is definitely a possibility with leaking of warm, moist air through your wall assembly during the winter conditions. So the materials that you use for air barrier are not too different than what I showed for your vapor barrier and spoke to for your vapor barrier. So the polyethylene sheet, which is typically only used in low-rise residential, so most homes, they'll use the continuous vapor barrier as also your air barrier, primary air barrier system. Again, the rubberized sheet would be used for an air barrier, but in the previous image where I showed that rubberized asphalt, they have developed more breathable sheets that are airtight but are vapor permeable. In the case where you would have, say, two, I guess, components, one for a vapor control and one for an air barrier control, they've created these product lines where you don't create a vapor trap by introducing another controller like an air barrier. And again, you can have troweled on and sprayed on membranes that are both breathable and vapor tight. So there's a whole chemistry of products out in the marketplace. So I've alluded to this idea already. So controlled areas, you have one for air leakage and air control, and then you have the other for vapor control. And as I mentioned already, the amount of energy and moisture that you can lose through air leakage by far supersedes what you can transport through vapor. And it's really critical to have an airtight air barrier or a continuous air barrier system, because any little breach will result in movement of air, assuming you have a pressure difference, which you typically do in winter conditions, between the inside space and the outside space. If you were to have the same kind of breach in a vapor barrier, which is only functioning as a vapor barrier, the amount of extra molecules or vapor molecules that you'd have traveling through that vapor barrier would be quite little and slow, and you wouldn't be moving a lot of vapor in that condition. Having said that, if you're in a very high humidity environment like a swimming pool enclosure or museum, you still would like to have a more continuous, as much as continuous as possible, vapor barrier, because the amount of humidity that you're dealing with in those sort of extreme conditions can be quite high and will have a localized impact on your wall assembly. We generally try to have one product functioning both where you can, and it makes it a lot simpler to construct and easier to maintain construct and easier to ensure continuity from a, say, a construction standpoint. So the fourth control layer would be for heat. We've all heard of insulation or thermal insulation. This control layer, as you know, is quite important when you're looking at energy consumption associated with buildings. I thought that this is something that I learned later in my career, that sound insulation is very similar to thermal insulation. So I designed a few sound studios, and they had to enclose certain rooms with the sound insulation, and which was separate than from, say, the roof in the case that I was dealing with. And we ended up with actually some problems in the wall design or the roof design when we had to account for the amount of sound insulation that was being used in thermal insulation and looking at placement of products. So just something to be mindful of, that sound insulation does have very similar thermal properties as thermal insulation. So I found thermal insulation again late in my career, relatively late in my early career, about what is thermal insulation and how does it work? Because you can see, I'll show you some different products. But the main takeaway is that there's a gas in the insulation, whether it's air in say fiberglass type insulations or mineral wool insulation. The reality is, by volume, those products are, anywhere between 75 and 90%, 95% air, greater than, which that's where you get most of your, if not all of your insulating value. So you'll see a product that's very rigid or might be heavier than, say, a piece of fiberglass insulation, which I'll show you some images of. The reality is all your R value is really driven by the trapped air in the case of these mineral wool or fiberglass insulation. And in the case of spray urethane foam, it would be the blowing agent that's used to sort of create these pockets of space in the insulation. Again, when you look by volume, these things are primarily air. And then there's rigid board insulations, and I'm going to show you different images for these different products, but there's polyisocyanurate, which is a type of plastic extruded. And these are all, I guess, different types of plastics, if you will. Very different manufacturing processes, but the end result is that each one of these products have either a blowing agent in them or air, and they're greater than 90% by volume, either that gas or air, which gives it its insulating power. Not unlike, I guess, down feathers and whatnot that you would have in jackets. Like at the end of the day, you get that insulating power because of the trapped air. So when you look at insulation fiberglass, you're poking and prodding at it, and the reality is, by volume, this is primarily air, 75 to 80% or more. Same thing with mineral wool insulation. Again, we're talking about bat form. So bat form would mean that it's a little softer and less rigid. The binders that they use in the insulation affect its rigidity. You can take, say, mineral wool insulation from bat form and sort of address its composition and make it something that's a little bit more rigid, sort of semi-rigid, and you'd use this on the outside of the wall as opposed to within a stud cavity. Foam plastics, or I could call them rigid insulations. Here would be expanded polystyrene insulation. This is similar to what you would have, say, packaged electronic equipment, where you have the white bead type insulation. There's a whole variety of different densities that you can get with this beadboard insulation. But again, if you were to look at these products and feel them, you'd think there's some substance to them and whatnot. But again, they're by volume primarily air or a gas that's used to manufacture the particular product. The one product on the right side here, the right side, the spray polyurethane foam, it's a product that's probably been around, I guess, actively in the construction industry, probably the last 15 to 20 years. It's a sprayed on system, and there's a variety of products out there. The one that's generally used in exterior wall construction is what's called a medium density closed cell polyurethane foam. And again, it's a two-part foam, and this person's using, as you can see, the nozzle, and it mixes within the nozzle, and it hits the substrate sort of in the mixed state, and it expands a fair amount, and that's how you end up with your insulating power. And I mentioned when we were looking at the vapor retarder sort of product in that ceiling, and they use this insulation. This insulation actually has very good vapor barrier qualities to it also, so it can function as insulation and also as a vapor barrier for the right thickness, the right construction. Sorry. Oh, another thing about these insulations, if you were to, it's funny, you can see this blue insulation on docks, say at cottages and whatnot. In a very submerged condition where it stays wet on both sides, it actually absorbs a fair amount of water, and a 4x8 sheet board would be extremely hard to pick up, which a lift, because of the amount of water that it could absorb. So if we went back to that idea of having, at least 95% air or space inside these boards, that means that space can get filled up with something. In the case of, say an inverted roof, which we'll talk a little bit later. Or in the case of a dock, the product will pick up a lot of water and absorb it in time if it stays in a very wet and submerged condition. So we talked about all these control layers now, and I wanted to speak a little bit too about what a perfect wall would be. And again, there's different ideas and concepts, but the main concept for this perfect wall is to really have your stud cavity clear of any insulation, which allows it to dry out should you ever get moisture in that wall assembly. And the other thing is when you're dealing with insulation within your stud cavity, which is what's represented by this sort of space here, white space, that usually the insulation and I'll speak to a little bit more about this, I'll show you some images, the insulation loses its R value. The R value is sort of short-circuited because of the thermal bridging that ends up occurring through the studs. And by having the insulation outboard of your studs, you really get maximum efficiency out of your insulation. You can have on the order of anywhere between 20 and 50% loss of R value of your insulation within this cavity, depending on how much insulation you have outboard. When we'll talk about thermal bridging and breaks and how to deal with that. So in this case here, where you have all your insulation outboard, we'd actually have your control layers doubled up, where you'd have your vapor barrier and your air barrier in one component, which would be that black line. And then your insulation outboard of that. And the insulation, again, could vary based on wall assembly. This is not necessarily your most efficient wall assembly in terms of space, meaning that if you're really trying to achieve a very, very high performance wall assembly, say an R40, that would mean that the insulation outboard of your studs would get fairly thick, which means the overall thickness of your wall would get obviously larger. I introduced this idea of a hybrid wall where we actually, in the next slide, where we talk about inserting a little bit of insulation within that cavity. So in this perfect wall, you have some sort of cladding system. Again, could be brick vinyl, which is your main rain screen, deals with 98% of the water that's hitting the wall. Then you have sort of redundancy, or this cavity system that allows the wall to either drain water through flashings and/or have ventilation to dry that wall out through ventilation and convection. And I already talked to you about having your air and vapor barrier in one plane, and it's also protected by the insulation, so it's kept in a very stable environment from thermal cycling and what have you. And the whole idea about being perfect, it's your wall assembly stays dry. The sensitive parts of your wall assembly, which is typically your studs and your sheathing, outboard of your studs. And then the other idea is that it maximizes the efficiency of your insulation. And by dealing with the thermal breaks or thermal bridging, sorry. And then the other aspect is that this wall assembly actually could work in almost any climate, and whether it's winter or summer too. There's a bit of a caveat there, but it is a very resilient and wall assembly that can really function in a variety of different conditions. And from a construction standpoint, this air barrier, we talked about continuity, achieving continuity when it's outboard of your wall construction, your studs and whatnot, penetration safe for electrical and whatnot. It's a lot easier to achieve 100% air tightness in that plane. Oops, sorry. So I alluded to this idea of a hybrid, and the hybrid here would be to add a bit of insulation within your cavity to take advantage of your cavity if you're really tight on space over the overall thickness of your wall assembly. We generally try to add sufficient insulation where you're not needing to introduce a vapor barrier on the interior, just to try to keep the wall to dry to the interior. If you add a vapor barrier, it really makes it a lot harder for the wall assembly to dry to the interior. And two, adding another construction component just adds to cost and possibility of having issues. So what affects the thermal control layer? So we're talking about control layer number 4. It's thermal bridges. So what's a thermal bridge? Oh, before we get into thermal bridging, I wanted to talk a little bit about definitions, because you're going to see this a lot, I think, in looking at reports and even architectural drawings and whatnot. So there's something called nominal R value, and that's really the R value of the insulation on its own. If you were to just get packaged insulation, that's the R value. Many people report nominal R value, and it really does not indicate the true performance of your wall assembly from a thermal standpoint. As we get a little more technical, there's something called clear field R value, and that's really looking at a segment of wall from inside to outside and accounting for all the components giving you R value. So it's not only your insulation, but it's your sheathing, it's air films and whatnot, everything that comprises that wall assembly. But also includes for the thermal, what we would call thermal bridging, or components that really promote energy flow. So it would be your studs, and it would be connectors for your brick, for example, the ties, or connectors for your wall cladding assembly, which I'll show you later. But my point is, it's everything stay contained in a square foot or 2 square foot area of your wall assembly. Effective R value, the number that you would use, say, in an energy model, would be exactly that. It would be your R value. You take your clear field value, and now you would add additional thermal losses to it associated with the building itself, meaning its configuration. So if you have balconies, which can be thermally heavy from an energy loss standpoint, or shelf angle systems that support brick veneer. So these heavier type components that are beyond, say, looking at a 2 foot by 2 foot square wall area, that will affect the overall R value of a wall assembly. That's what we would call effective. So what is a thermal bridge? It's basically anything that has a higher thermal transmittance. So something that moves energy more quickly than, say, surrounding component in the case of insulation. So my simple definition is anything that penetrates or interrupts the insulation plane that isn't insulation. So the next part of this presentation really focuses on quite a bit on thermal bridges, because these typically are I guess not necessarily well understood, and it will have a large impact on your overall effective R value of your wall assembly, things that need to be considered. So we talked about, one of the main impacts is you can have, depending, there's a lot packed into this number, 50% R value loss. So, if we talked about nominal, looking at your insulation, say for a 6-inch wall stud might be a nominal R value of 24, you can easily have 50% loss of that R value based on thermal bridging. So from 24 or 25, you're going down to R12 simply because of the components and how you've arranged the components within that wall assembly. So it can be fairly high. The other issue with thermal bridging is that you can have localized cold spots within your wall assembly where you're dropping below the dew point temperature, which I never talked about, but so the dew point temperature would be the temperature at which you're getting condensation within your wall assembly. And you can have thermal bridges within your wall assembly, and I'll show you some conditions where that exists, and have localized areas of condensation, which again could promote mold and corrosion or rot of your framing system. And then again, depending on the extent of the thermal bridging, you can also get localized areas with cold spots and have some sort of occupant discomfort issues. So the next couple of slides are going to just talk about, thermal bridges that you would look at or see in a building, make you aware of what you'd be looking at. So parapets would be a very common thermal bridge that is not only thermal, but also is an air leakage issue. And looking at the continuity of your insulation from your wall to your roof is important. So having an eye for the parapets, which are occurring at the tops of your building, is quite important. The other would be balconies. Balconies can have a major impact on thermal performance of your wall assembly. Pretty significant, obviously, either locally, because you can have a very cold floor in the case of concrete type balconies, which a majority of balconies are built. If you're building these balconies out of wood framing, the thermal bridge is not as significant. Still material, but nowhere near similar to, say, concrete, because the conductivity of concrete is just so much higher than, say, wood. But these balconies can have a major impact on your overall effective R value of the envelope. So similar to balconies, you can have canopy, generally it's canopies or soffit type conditions. These sorts of structural penetrations that are structural framing members that are coming or protruding through your wall assembly, again, can have a major impact on your effective R value and should be considered. They also, again, in all these three conditions, as I mentioned earlier, can have localized impacts on condensation and definitely need to be studied based on what sort of humidity levels you're having on the interior during winter conditions. Oh, I didn't link these very well, sorry. So some other sources, so studs, I alluded to studs in your wall assembly. So this is a section, sort of bird's eye view looking down on a wall assembly where you have insulation and your steel studs in this case. As I said, in this sort of assembly, you can experience at least 50% R value loss because of the stud penetration through. The conductivity of steel, and I'm going to show you some materials, are quite high, or is quite high compared to insulation. And because it's so much higher that it just moves a lot of energy through your wall assembly. The other condition would be brick veneer supports. So I have a whole section on this where we talk about brick veneer supports. These, what you're looking at here is actually a separated thermally broken system, but it still has a large impact on thermal performance, even though the insulation travels behind the shelf angle, which supports the brick. The connectors for the shelf angle do have a large impact. And in the case of, say, thin veneer cladding support systems like metal panels or wood siding, the connection points, again, for the support of that cladding system does have, anywhere between, say, 10 to 25% impact on R value. These shelf angles can have on the order of 30% impact on R value. And I'm talking about R value on the entire wall assembly, not just locally. Although I didn't say anything about, I said we wouldn't speak about windows, but I thought I'd throw this in there about, windows are supposed to be in plane with your insulation. And in this case, it is. The support that you have for your window has actually a large impact on thermal performance. So being prudent in selecting that material, goes a long way to ensuring that we have the right performance and maximize the performance of the whole window wall assembly in this area. So I alluded to, I probably should have had this slide earlier. Why is steel studs so detrimental? So if here, K value or thermal conductivity is the measure that we use for the metric for measurement for air, energy loss or energy flow. So fiberglass is 0.04. Softwood, most woods are in this area of 0.12. PVC, say vinyl, again, it's very similar. I would consider, wood and vinyl kind of all in the same family, to be honest with you, when you look at the other products that we use in construction. So aluminum is 205. So this is not thermally broken aluminum, it's just straight aluminum alloy. So the difference between an aluminum sheet and, say, stainless steel sheet is actually fairly high. So when I look at thermal bridging and I look at components, I sort of have the metal component that I look at, and then the non-metallic family of materials, as I call it. So although, stainless steel is a lot higher than fiberglass or wood or PVC, it's substantially lower than aluminum or carbon steel for that matter. Carbon steel or galvanized steel, if you take mild steel and you galvanize it, it's not as bad as aluminum, but it's anywhere about 3 times as conductive as stainless steel. And you'll see in some of the components that we're going to talk about, stainless steel is often used as the material of choice because its conductivity is a lot less, and you generally need steel in some instances for structural strength. Thermal bridging, so, there's different ways. There's a 2D and 3D modeling programs that are used that we typically use. There's a guide out there that's called the Building Envelope Thermal Bridging Guide. It was developed by Morrison Hershfield for a couple of organizations. It's a good guide to start with. I encourage you to review it. But there's a lot of information baked into the numbers that they present, and you really need to understand the components that they're analyzing. So it's a good first start, but again, you'd have to look at it with caution and make sure that you understand what the numbers that you're extracting from the study. We generally go back to first principles and do our own 2D and 3D modeling of the details to ensure accuracy. So thermal bridging mitigation, how do we mitigate? So with stud walls, we generally mitigate by introducing insulation. If you're going to have insulation within your stud wall, you mitigate by introducing exterior insulation. So in this case here, what I'm trying to show you between wood, so here's what you would consider nominal insulation, the bad insulation R19 in both cases. On the right at the top, we introduce steel stud, and the effective R, and this is fiberglass insulation because the R values would be different if you use mineral wool. Mineral wool is a bit higher. So you can see the amount of loss that ends up happening simply by introducing these steel studs on 16-inch centers. The same spacing with wood, you don't have anywhere near as much loss, but you still encounter some loss that occurs because wood by its nature conducts more heat than, say, the insulation. So to mitigate the R value loss or energy loss that's associated with the studs, you would introduce some exterior insulation, and that's sort of muting the flow of energy through the studs. Done just a quick calculation. With a 2-inch, in the case of the steel stud, we end up going from R7 to R19 by adding R10. So we're going to do the math. We went from, if you were to take the R7, add 10 to that, you'd be 17, but we actually got 19 out of it because we ended up reducing the impact of the steel studs. It's not a huge change, to be honest with you. That's another thing that I learned early in my career is like even if we added 4 inches of insulation, still the studs do have an impact. Ultimately, the best efficiency, again, for your insulation is to have it outboard your studs if you really wanted to maximize R value per inch. And we really encourage that if you're going to be using steel studs, which is what we talked about earlier. Perfect wall, no insulation in your stud cavity. There's a limitation to that. Again, if you have a limited thickness of wall that you can work with, then you're going to have to utilize that stud cavity. You can do it. There's ways to do it. It's done often. It's just not necessarily ideal from a thermal standpoint. So thermal bridging mitigation, what do you do at parapets? You try to make your insulation continuous around the parapet. This parapet's shown as a concrete block wall as opposed to steel stud. If it was a steel stud, you'd have insulation within your steel studs, and you'd have insulation wrapping the exterior. For balconies, this is a bit of a tough one. I mean, a wood balcony, you probably wouldn't be too worried. However, if you're into concrete balconies, there's a few products on the market. They're a little bit expensive, but they work. This would be the shock system, where they actually use stainless steel reinforcement, and they have a thermal break between the interior slab. The interior slab, which would be on your left or on your right, and then your exterior slab in the balcony, what you'd be standing on in the exterior. They actually have stainless steel within this module unit that's used. It isn't cheap, but it is quite effective. And this is what you would use for, say, a concrete type condition. Or the other way to do it is actually have your balcony completely separated, which means you'd have a separate structural system supporting your balcony system and not have any sort of connection between interior and exterior, that structural system. Oh, and structural penetration. So we talked about a canopy. I showed a canopy coming out, or say a second floor for whatever reason. I've seen balconies built out of steel. So when you have a structural connection that you need to maintain, there are structural thermal breaks. Armortherm's one. There's a few companies out there that produce these very high density products that actually work well at reducing the amount of transfer between the interior steel and the exterior steel. The placement of this thermal break is really important. It's shown here to be in plane with the insulation. This thermal break would have no value if it was, say, put out here, for example. So positioning the thermal breaks are key. Same thing with the here at the balcony, positioning it in line with the wall thermal insulation is really important too. So placement of thermal breaks, critical. We've had clients wanting the thermal breaks for whatever reason outboard and afoot, and we said there's no point in putting it because it's of no value there, because the steel, just to the right of it, for example, would be still exposed to the cold weather and would transfer. I mentioned thermal bridging associated with brick veneer. So this is a pretty important one because there's a lot of brick veneer and it's wall assemblies, and it's not a well understood concept from a thermal standpoint. So I want to spend a bit of time here. So back in, say, the 80s, maybe 60s to 80s, the typical shelf angle attachment was actually right straight to the structure. So you'd have your structure, a concrete wall, here's your slab, and the shelf angle, which is a bent piece of steel, if you will, or a rolled piece of steel, was actually tied straight back to the structure. So as you can see, you would actually have this thermal bridge between the steel or through the horizontal piece up through the vertical and into the concrete. So it segmented or bisected the insulation, and you had this sort of high wave energy. This would be on order of 50% thermal loss in this sort of configuration. So people got a bit smarter and said, okay, we're going to have this thermally broken system, and what we're going to do is we're going to set the shelf angle off of the wall. So you have these sort of connectors that push the shelf angle off the wall, but you need these connectors again to tie the shelf angle back to the structure. The devil's in the detail. So if you didn't have the steel connecting the shelf angle back, it'd be great. You'd actually have no thermal bridge because the insulation would travel behind the insulation. So in this case here, showing the shelf angle set off of the floor slab with this type of connector, which is, say, this one here, and the insulation travels behind it. The problem is this connector. So the connector ends up being fairly thick, and this is the important piece, is the frequency of these connectors. So the structural engineers will go design these things sort of the way they've been designed for the last 30, 40 years, maybe 30 years. And there's not a lot of thought to the density of these connectors and how frequent they are. And that has a major impact on your R value. Like it's huge. To the tune of, if you're on, say, a 2-foot spacing, which is typically what is used, you'd still have a 30% loss in R value. So it's not a lot better than the 50%, especially when you look at all the effort put into it. The key is to get this spacing out to about 1 meter. If you can get them out to 1 meter between connection points, not doubled up, single, 1 meter single spacing, then you can achieve maybe about only a 15% loss, which is a lot better. And pardon me, I'm talking about a 9-foot high wall. So if you're in a hospital and you're dealing with a, I don't know, 18-foot wall, then obviously the impact of this thermal bridge is going to be less, because these numbers I'm referring to are actually the overall impact on the entire wall assembly for a given floor. It's not a localized impact. So locally, you probably would have a 70 or 80% loss. But when you average that out over the entire wall, you end up, in the case of this condition here, 50% loss. And these conditions here, anywhere between 15 and 30, depending on the spacing. So it's pretty substantial. The other item for brick is, we know this is to carry the gravity load, so you're carrying the full load of the brick, but in order to stop the brick from falling off the building, say from suction due to wind, you have these brick ties. And the brick ties come in different forms. And these ties are on a fairly high density, and so they do add up and have an impact on R value. They can be on the order of 10 to 15%, depending on how thick your insulation is and depending on the type of tie back that you use. So we try to specify stainless steel, as I mentioned. They're about 3 times less conductive than mild steel or galvanized steel. There's been a lot of research in these products too, where they've tried to minimize the amount of steel, hence these holes and whatnot. So you're minimizing the amount of steel that's actually penetrating through your insulation. Just as a side note, this little yellow tab is actually for insulation retention. So you reduce your thermal bridging. And then they've come out with fancier type thermal tiebacks where you're really minimizing the amount of steel going through your insulation, and the fastener is really limited to the back. Also talked about another popular cladding system, whether it be aluminum panels or even vinyl siding and whatnot. You can get into these point connection. So these point attachments, there's a whole, I guess, variety, and you're kind of seeing them across the screen here. The first ones that have come out were steel-based, either stainless steel or mild steel, and you're really getting these sort of discrete connection points for your cladding system. They've evolved to fiberglass, and one piece that I'm showing here, this Cascadia fiberglass, it's actually great from a thermal conduction standpoint because it's made out of fiberglass. If you recall on that graph, it was sort of the leftmost product. It's quite low conductivity. But the key with this fiberglass, interesting note, is these 2 holes represent large fasteners that have to penetrate the entire clip in order to support the clip. Those 2 fasteners actually have a large impact on R value to the tune of 10 to 15%, again, depending on density. Other products available in the market are fiberglass too, but the fasteners are actually at the back of the clip, which means that they don't penetrate the insulation. So you really only have the fiberglass that's penetrating the insulation. So the net impact is a lot less on thermal reduction. Some of the things to consider when you're looking at these clips, which I'm a little bit, to be honest with you, a little bit hesitant on these fiberglass ones. I'm worried about fire and what happens if you do have a fire. Does your cladding end up falling off the building? I really encourage you if you're looking at combustible buildings to look at the fire requirements for the wall construction and whether or not these fiberglass connection products work for that particular building. Another thermal bridge mitigation when you're looking at these veneer walls or these rain screen walls is looking at the insulation attachment. So I went back here. Brick veneers have these ties have the clip sort of built into it. When you get into say these wall assemblies here, you're relying on the channels. Sometimes you don't have enough channel placement, and it's the configuration of the channel to support the insulation. So you have to introduce these pins. Well, these pins can actually have, like the ties for brick can actually have, they're generally metallic, aluminum or steel. They generally have can have a large impact again on their density. It's like strictly a wire, but again, we talked about the thermal conductivity. You can lose a lot of energy through these. The industry's wised up, and other products have come out. And I've used these quite often. These tube washers, they're actually made out of plastic, and the fastener is just at the end of the tube washer. So you end up with really good thermal performance from these components because of the lack of metal transferring or getting right through the entire wall assembly or through the insulation. So I'll just talk quickly again about some sort of, I would say, envelope configurations to consider. We're running out of time, so I'm going to whiz through these. So soffits are something that you encounter often, and the question is whether or not you construct these as cold soffits or heated soffits or cold soffits. If you go with the cold soffit or heated soffit, pardon me, you're dropping your insulation plane and you're creating this sort of warm space below your floor slab. And it really allows for much warmer sort of floor condition, and allows you to run mechanical systems or utility systems through here that it might be temperature sensitive, like plumbing, for example. So the floor ends up being a lot more comfortable for your occupants. So if it's more suitable for, say, for a living space, so like a long-term facility, I would consider using sort of heated soffit. Already alluded to the idea of having utilities and making sure that things that need to stay warm, like water pipes or sprinkler pipes, that can stay within this heated space. A little bit more expensive because there's more framing and whatnot that you have to consider, and air barrier tightness and thermal bridging is going to be a lot more because you have all these supports that have to come back to the structure through your insulation. Cold soffit is where you have the insulation directly applied to your floor slab. So this space basically becomes ventilated, which we encourage because you don't want moisture buildup in this cold soffit space. And it's generally easier to construct. One of the issues is, although it may not seem, your floor slab might have some cooler conditions depending on how your HVAC works and whether or not you can get warm air to the top surface, but we're only talking about maybe a degree difference. Some people are more sensitive to that sort of degree change, but there could be a degree change. Again, we think it works well for office space or non-living space, meaning people aren't. It's not like a living room or if it was storage or garage space or what have you, it'd be fine. Can be cheaper to build, and there's less operating costs because you're not heating and conditioning this sort of volume of space as you would be in a heated soffit. Generally, if you go the cold soffit, we advise increasing the insulation again just to make the likelihood of having a temperature issue at the top surface here less. Oh, this didn't work out either. I missed that. Sorry. So flat roofs and pitched roofs. I like talking about roofing because it's actually pretty important. There's a lot of availability here. So flat roof would be, by definition, anything less than 2%. So this would be here, a flat roof, kind of obvious. Advantages, it gives you space to put mechanical units. You can put a green roof. You can put solar panels on it a little more easy than you can on a sloped roof. You can put on sloped roof, but not that easy. Not really recommended for me, to be honest with you, unless you have no alternatives. The main challenge with this is that water and durability of the membranes, it goes through a lot more cycling than, say, a pitched roof, for example. Thermal cycling and environmental conditions and wear and tear. Pitched roofs, they're nice from a maintenance standpoint. Not a lot of maintenance required on them, and snow dealing with snow and whatnot's easy. But I like the fact that you can generally have an attic space, and you can include a lot more insulation in that sort of attic space, so you can get a lot higher R values without really without a lot of money, because the insulations are usually used in attics are a little more economical than flat roofing, where you're dealing with more foam plastics or mineral wools that are not cheap. In the flat roof category, there are two types. There's what's known as conventional assembly here on your right, and conventional means wave roofs were designed many from, I guess, the early days of flat roofs, where the membrane was exposed to foot traffic and exposed to the environment. Hence the word conventional. Since then, people wised up. I don't know if it was in the 80s, maybe earlier than it would have been probably in the 70s, maybe late 60s. The idea of a protected membrane roof came about, where you're actually putting the membrane on your structure and then protecting it from with insulation. So you're using a different type of insulation than what you would use in say a conventional roof, one that's not susceptible to moisture as much. So you're protecting it from thermal cycling, you're protecting it from, people walking on it and whatnot. So generally speaking, the protected membrane has a much longer service life. And our ideal deck would be the concrete deck. You can get on the order of 50%, 30 to 50% increased in service life as compared to a conventional roof in our experience.
Paul, just to note, you are at time. I hate to stop you. Do you think you can
Yeah,
wrap
we're
it
pretty
up in a
much
couple of
done.
minutes?
Yeah, we're
Fantastic.
pretty much
Thanks.
done. Yeah. So I've already talked about the advantages and disadvantages of these. So our preference is to go inverted roofs. And foundation wall, this will be really quick. We prefer to insulate on the exterior because you take into account the thermal mass of your wall assembly, as opposed to on the interior here. There's some issues with moisture and whatnot. Having your insulation outboard really allows for your wall to stay dry should you have leaks and what have you. The takeaways: building envelope design requires control of heat, air, moisture, and those controllers are really important. Water and moisture control is critical for durability, and thermal bridging, you have to give that a lot of thought because it can have a large impact on the performance of your wall assembly. And thermal breaks are not equal. There's a typo, sorry. There is a lot baked into thermal breaks, so don't get, I guess, really study what a thermal break is and what its performance is going to be when you're looking at wall design. Thank you for your time. Sorry, there was a lot to cover.
No, every one of our speakers, Alex even started the morning just saying he could take the whole week and just talk about
Yeah,
how to
definitely
set
could take the
performance
whole week.
standards. Yeah, we're asking you for a lifetime of work in an hour's time. So thank you so much. That was incredible. Just for the students, there is a 15-minute break now. Paul, if you're amenable to staying on for a couple of minutes in case some
No
students do
problem.
have questions, that would be amazing.
Absolutely.
I know there's a question you did mention between flat roofs and sloped roofs. You were saying that an advantage of flat roofs is you can put solar on them, but you can also put solar on.
Yes, you can.
Yeah.
Just not as easy.
Yeah. Terrific. And just open up your cameras and ask your questions, students.
You don't have to wait on, you can just ask them.
Okay, I keep trying to find where my hand is to raise my hand. So I'm like doing this in in terms of cladding, you were going through all the thermal bridging. I'm understanding that there is no such thing as cladding with no thermal bridging then? Does that even exist? Like, I'm not used to like
Yes, I say
higher.
that it does exist, and it does exist, and the one system that exists, it would be an adhered. Have you heard of EFIS, exterior insulation and finish system? So exterior, it looks like people call it stucco. So exterior insulation and finish systems, it's an insulated board that's applied to the exterior of your sheathing, and that board will have a reinforced cementitious coating. Generally, it's a cementitious coating, polymer modified cementitious coating. Oops, sorry. I will actually I can bring something on my screen if you guys. So the short answer is yes. And it would be an adhered system. And with that system, because it's adhered, it doesn't have any thermal bridging to it.
I would assume that there's a possibility for it to not be as long lasting then maybe if it's adhered, the glue.
So, well, if you ask Paul, me, I love the system. It can last a very long time. It has a bad rap in the industry because of it was built. It went through a period where there wasn't enough oversight, and so a lot of buildings were built with it, and there were a lot of problems with it. The reality is, if it's put on properly, it can last a long time. And I'm a big proponent of it, to be honest with you. So it can be done properly with not a lot of effort. So this is what it looks like. So you have your steel studs, your sheathing. Can you see my screen?
Oh, sorry, I stopped your sharing so we could see faces. Please go ahead.
Now I get to share again. I have to pick my screen, sorry. Okay. Sure. So here would be your steel stud, your sheathing. You would have a water vapor barrier here, which would be this mustard color, and then those ribbons is what you would adhere your insulation board with. And today they're using spray foam. It's almost indestructible, to be honest with you. It's very robust. The key is having a really good lamina. So they call it a lamina, which is fiberglass reinforcement, a cementitious coating. And they've gotten really elaborate over recently, I would say the last 10 years, where you can put different finishes on it to make it look like brick or metal panel or stone. But yeah, you can essentially get 100% efficiency out of this. Well, maybe 98, 95%. There are cases with EIFs that you can mechanically fasten to, in which case, obviously, you're going to have a reduction in R value.
I was just gonna ask one last question. Is there a limitation on how many stories you could use that for?
No. However, if you ask Paul, I would probably mechanically fasten unless I had 24-hour observation of the contractors installing it, because it's just so sensitive to installation. And I'm kind of kidding when I'm saying 24 hours, just I'd have a very vigilant QC program to make sure that things are being installed properly.
If there are no more questions. Yes, let's see if there's any questions in the chat. We do have one here from Obi. They were wondering if you hadn't already mentioned, are there any university courses, certifications that would help one to learn more about building envelope and assembly?
Yes. So there's the BSO, Building Science. BSO. It used to be called BSSO. So there is a BSO program that is outside of school. But if you're talking about schools, the U of T has program, Ryerson's got programs. I don't think they're continuing education, so they would all be Ryerson, U of T. Waterloo has a strong program also. So it is available, definitely. So again, you could have the school program or you can have outside school, and then I'm gonna Google what BSO stands for. Jesus.
I had a question. I'll turn my video on. But you spoke before about my mitigating thermal bridges, and you specified about not insulating the cavity. So can you clarify something when you're talking about that? Is the assumption that you're either having the insulation outside in front of the cavity or just in the cavity?
Sure. Yeah. Sorry, I wasn't clear about that. So if you're not insulating in the cavity, then all the insulation would be exterior of the studs and the sheathing.
Okay.
And then
And
I
then,
mentioned the hybrid wall where you would have out exterior insulation plus some within the cavity.
okay. Okay, because yeah, I just figured if you would have some insulation surrounding like your steel studs, that might help with the thermal bridging, as long as there's another form of insulation.
Yeah, honestly, the steel studs they're terrible. Like they move so much energy.
Hmm.
It's to me it's if you had no other choice, it's a waste of insulation to put it in your cavity.
Oh, okay, I get what you're saying. Okay,
Because the steel studs just you lose way too much energy through the steel stud.
okay, that makes sense.
So yeah, if you may recall the table that I was showing where the conductivity of steel was 50 and the conductivity of wood is 0.12. So that gives you an idea of how much more energy a steel stud can move, no matter it being maybe 2 millimeters thick in terms of the wall diameter. And the it's called building science specialist. It's BSS. So it's not BSO. So if you type in BSS, Google search building science, and then the website will come up and you can see.
There's a link in the chat now.
Oh, awesome. Thank you.
I appreciate you clarifying that for me, Paul. Thank you.
Oh, yeah, no problem. Sorry, it wasn't clear.
Okay, that was awesome. Thank you so much, Paul. And we've invited you to our LinkedIn group in case the students would like to connect with you. I hope that's okay.
Absolutely.
And if you don't mind sending, I had a number of students asking me for your presentation because it was so chock full of information. So if you wouldn't mind sharing that with us, that would be amazing. Terrific. Thank you so much.
So we are happy to have Jacek and Bhavesh with us here from the city of Durham, and they're going to be doing a presentation on the city of Durham standards, as Meaghan and Andres mentioned in their talk.
Okay, hi everyone. My name is Jacek Sochacki. I'm the manager of design construction.
Please feel free if you want to share your screen or if you just want to talk, however you'd like to.
Yeah. We're gonna share the screen, so Bhavesh is gonna start the presentation. I think he can share the screen.
Yeah, sure. It's opening up. Just give me one moment.
If you are having any technical difficulties as well, please let me know because we might be able to help out.
Yeah, no worries. I'm just on the road, so I'm just grabbing this in between. Just pulled over. So okay.
We can see you.
Perfect. All right. Do I guess want us to start? We're good?
Yep. Please feel free to take it away.
Okay, so my name is Jacek Sochacki. I'm the manager of design, construction, and asset management group for the Durham region. And my colleague is Bhavesh Madhvani, and he's a policy analyst that works with my asset management team. Durham region, we're the upper tier municipality. We have a number of cities and municipalities and under us, roughly 7. So Durham region is just east of Toronto, for those who don't know. And we're probably, I think, area-wise, we're the biggest land-wise municipality, regional municipality in the Golden Horseshoe area. So we're going to be talking about our Durham standards. So at some point in 2020, roughly, the council decided that we're going to hit our target of being GHG emission-free by 2045. That requires essentially all the everything that we do to be GHG emission free. But from my perspective, it looks at the facilities. So we're looking at all the new builds that we're doing, all the new building that we're doing has to be GHG emission free, and then also we're going to be looking at changing over the facilities we currently own to be GHG emission free by that time. So looking at deep energy retrofit. Just to tell you the difference about what facilities do we own. So region, so when you look at the city and the region, we kind of do different, have a little bit different functions. We deal with, for example, with water and sewer, as well as buses, so transit. We do have long-term care facilities. We do have, daycare facilities. We also have large depots, few office spaces. We do have a health department. That's just, and then we do have a relatively large stock of social housing units. I believe right now, currently, we're running about 14 to 1500 units. I think 1429. I think it's the actual number. So as you can see, our portfolio varies, right? And we also have a police and EMS facilities are under us as well. So currently, we're looking about 65 large facilities in that portfolio, and about 300 in total, and that includes like pumping stations and things of that nature. So relatively smaller facilities. And the decision was made at the time when we declared the climate emergency that we would probably start looking. Actually, we were working on the Durham standard, which is a holistic standard for us to be able to hit all the corporation goals. Also, what we noticed at the same time, that there was a number of lower tier municipalities came up with their own standards. And, since we're the higher tier municipality, we build in all of the lower ones. We wanted to make sure that we're going to have a standard that's going to be overarching and it's going to be building on top of everything else. And if I need to put a building someplace, once I design it, I'm able to move it around if I have to. So we can skip to the next slide. All right, so this is just a quick understanding what we're going to do. So we're going to do a little bit of overview of the actual standard. So standard was developed a number of years. We're actually going to go into that, and includes a number of kind of important, I guess, factors or targets that we want to achieve as a higher tier municipality, and it helps us to get there. So overview, structure, capital project implementation, and we're going to do administrative implementation. Okay, so just jump to the next one. All right, let's go through the overview. Okay. So Durham Regional Facility Design, Construction, Asset Management team. So this is the division that I manage. We developed the Durham standard. This is the version 1 of the standard itself. And the standard, actually, we went to the council to have it approved as well after the development. So the standards right now is something that we built in. So our buildings are built to this standard. So this really was designed, like we said, to align planning and delivery of capital project across all of regional assets with various strategies. And when we look at that, we look at have different climate emergency, we got corporate strategic plan, climate action plan, asset management plan and policies, as well as long-term financial framework that actually helps us to deliver all these projects. So we're going to kind of run through this. We're going to show you what this looks like. But overall, it's kind of what we initially already talked on a previous slide, which is the overview, the structure of this, the organizational framework of the standard, the capital project implementation, administration, and the development process itself. How did it happen? Okay, let's go to the next one. All right. So like I said previously, the intention of the standard is to set the minimum performance level required for all the regional capital projects. And this specifically looks at the new facilities very it's much in depth actually when you look at this. So really the main goals when you look at this, we got the accessibility, inclusivity that we need to meet with all our buildings. We have space optimization, so we actually develop our own space standards, closely following the federal standard UP 2.0, as well as lessons learned from pilots that we have done throughout the region. And sustainability and resilience being really a big piece as well of this. So it includes GHG emission reductions and targets, assets resilience, right? Like we do own a number of buildings that are critical buildings to the infrastructure, and as well if there are any emergencies, we are actually the ones actually run the emergency services with the help of lower tier municipalities. So we want to ensure that our police station in case of emergency is still running, and same thing with the EMS station. So those are very important pieces. And to outline the process, we want to achieve the best value option, which is also the financial financial aspect of these projects, and we want to make sure that we're going to look at everything, and at the same time we're financially, fiscally responsible. Okay, next. All right, and our standard, the way we developed it, we looked at various standards. We're going to show you guys four, but it's essentially developed to be used by three key user groups. So what do we mean by that? So our regional staff is one of the user groups that actually manages the standards, and they manage procurement of the delivery of the different projects. They need to understand what we're purchasing. The consultants, so anytime the project gets designed, on that aspect, from that perspective, they need to understand what they're designing it to, and then how they're going to be designing, as well as the contractors that actually build the project afterwards. They need to understand what our targets are in order for them to meet them as well and follow the drawings. Other stakeholders may use the standards for reference and for policies as well. And we've been sharing our standards with the lower tier municipalities for them to adopt it. And some of our northern municipalities like Clarington and Brock were expressing interest in actually adopting it as their own standard. All right. Let's go to the next one. All right. So this table outlines responsibilities that we came back with, and with different teams and different groups that would have it. So what we're really going through is to show you guys the framework of a standard, that it's not just a kind of a document that you just put out there. A lot of thought went into designing the standard and how it's going to be implemented, and how easy it's going to be to implement, and also for the various groups to understand how it works in order for them to hit the targets. So we have asset managers in my group, and as well as in finance when we have corporate asset managers, and they have certain responsibilities to do. So that's at the beginning of the project. So they kind of look at this and make sure that everything is aligned. Budgets are aligned with this, as well as the targets, and any feasibility studies that are being done are driving this, are in alignment. We're also going to be talking about like how is the standard being triggered on the smaller projects. So that's also falls within that group. The project delivery team. So we have a number of project managers that actually deliver various projects once they're designed. So they have to also understand what they're delivering and what the design is calling for. The procurement. So this is a whole division that we have at the region to actually helps us with the contracts, right? Like we follow very strict guidelines and policies when it comes to the procurement. Everything like we go out to tenders, we do our RFPs, and there are very, very strict procedures. How do we follow? We are spending public money, so we have to be very careful regarding that. Facility maintenance and operation division. This is a very important piece and very often overlooked. So when you look at facility maintenance and operations, the guys actually going to be operating the building afterwards, right? So we have to get their buy-in and their understanding to when we select certain equipment and certain solution that first of all, they're going to be able to support it. So they have enough, that they have staff on hand that is able to support certain systems or technologies, as well as some technologies we come in and they have like very rigorous maintenance schedule. So they need to understand that and kind of provide their comments to this. And the design consultants, obviously, the people that are actually designing our projects. When we talk about architects and engineers, they need to understand what they're designing to and why they're designing it that way, right? There's various ways of designing things and hitting the targets, but understanding the standard helps them to have one holistic document that helps them kind of deliver this. And then we talk about the product vendors and contractors. So this is the guys that actually built this. When they build the projects, they need to understand this as well, because we were asking for various submissions and during the construction process. So we can jump to the next one. All right. This kind of tells you where the standard applies to. So we're kind of clear on this as well. Like I said before, our biggest kind of line that we kind of drew on the standard is when we look at the water facilities. So we do own water treatment plants, as well as we own water supply plants. Now, these plants are mainly, they're mainly the emissions associated with those plants are mainly associated with the process, which we don't have control over. When you have a wastewater treatment process, it's very unique. It's very specific. Same thing with the, with the water supply process when it goes through the filters. and then chlorination before it gets to your house. We don't want to kind of mess that up. However, we are able to touch the office portion of those facilities as well as the envelope of those buildings. So that's kind of where we're going. And that's where we're kind of clearing it. Everything else that the region does, the standard applies to. So every facility that we own and we build, and we're gonna, we have to adhere to the standard. Okay, we can grab next. Okay, so this is kind of the big definition when we look at it. Like obviously any new construction that we're doing, we want to make sure that the standard is being followed. Now, when we look at the renovations, we looked at it the way where's the kind of breaking point, and we looked at it as project value over the building planning capital project over next 10 years, and then you look at or 15 years, and then you look at the CRV, which is current replacement value of the building. And we kind of determine that, are we expanding the facility, replacing just certain things? And there's certain pieces that, if we're touching, replacing heating, ventilation system, any air conditioning systems, that's a given that for us to have to follow the regional standard, right? Okay. We can jump to the next one. So the standards, the region first, corporate holistic building standard. That incorporates the features from existing external standards, and the first version obviously is then to be we kind of review it we're going to be reviewing that in 2 years, so that's actually coming up this year, and then we're going to be reviewing the standards and doing updates on it every 4 years. So I think we can jump to the next slide. This is just kind of tells you like our review process and giving updates on this. Bhavesh, do you want to maybe talk a little bit about this slide? Would you like to?
Yeah, sure. Sorry, I was struggling to find unmute button there.
I don't want to hug this. I don't want to hug this the whole time. So how about you talk about this a little bit as well?
Yes, yeah, sure. So as Jack mentioned in the previous slide, we'll be updating the standard every 4 years, and now that 4-year timeline is basically borrowed from how often the other area municipality standards are updated. So as you can see on this slide, Whitby and Toronto Green standard are updated every 4 years. Another LED standard. We have National Energy Code and Ontario Building Code mostly are updated every 4 years. So we kind of try to align the update process so that we are staying current with the market. At the same time, we are staying current with the other area municipality standards.
Yeah, so I think the big piece to let you guys know about this is like we looked at, like I said, our standards overarching. So we look at the lower tier municipalities as well as the Toronto Green Standard and various other pieces. It's just because we want to build out something new. Like there's obviously a lot of work went into these other standards, and we want to build up on top of it. We don't have to, we don't have to kind of look at it and reinvent the wheel in some way. We looked at all the pieces, and that was the big one for us. If we can build on something, we just want to make sure that what we're asking for is it's alignment with the regional strategies and regional goals. I think the big piece too that maybe I forgot to mention too is like when we look at the buildings before, we follow like ASHRAE or LEED standards, and the big piece that comes out of it that it's like really region doesn't have aspiration to own LEED buildings, or doesn't have aspiration to own like buildings that have a plaque on it that says it's a LEED certified building and I have to pay X amount of money every year to keep that plaque. Now we're interested to have buildings that perform to the same level, but the plaque is or designation wasn't really a big goal for us. And a lot of times what we found, either with LEED, BREEAM, or WELL, those different standards, they're great, but they don't align with us 100%. So that's why we came up with our own standard that kind of takes all the pieces that we feel are important and then align with our targets, and we kind of rolled it out that way. And as the regional targets change, that's why we have the review process as well as the standards is evolving. And same thing with Toronto Green Standard, right? They went through their revisions as well, and they have different targets being applied at different times. Okay, can go up to the next slide. So we can talk about structure of the standard itself a little bit. So Durham standards, really, it's designed we're trying to develop something that's going to be really friendly for the users. So you have Durham Standard User Guide, which is the document that kind of walks through everything. It makes everything a lot easier for the consultant to understand, especially the ones that are using it for the first time. We do have a number of design checklists. So each design checklist looks at the three major factors. So one is accessibility and inclusivity. Then we have space optimization, sustainability, and resilience design checklist. These checklists have number of targets within that, and they're basically Excel documents that are filled for every project where Durham Standard is enacted. Now, to help with that, we have design resources. So when you look at the life cycle impact analysis, that has to be done when we're using life cycle cost calculator, which is very important. Like anything that we do right now, especially on the equipment side, we're not doing simple playback. We're actually looking at life cycle cost analysis. What we found that looking at the life cycle of equipment comes with a lot of right really information for us to do, because sometimes you look at a piece of equipment, it's a little bit cheaper, it runs sometimes similarly, but then you're going to replace it twice in the same lifespan on another piece of equipment that's, let's just say, $50,000 more, right? So the life cycle piece is very important for us as well. We are starting to do embodied carbon reporting. So this is kind of, we're trying to follow the trends within the industry. Again, not everybody's reporting all this embodied carbon within their products. So for us, it's a trial. Right now, we just have to report it. We don't have targets set with that, but we feel it's still very important. Accessibility and inclusivity requirements. We have a huge section that kind of builds up on the building code to the next level and really strictly follows the regional policies on that end. We got our own BAS requirements. So building automation systems, we have a very strong team in our facility maintenance operation that looks at this. So I feel this is very important for us to be able to track everything that building does. So that information that comes in and all the sensors that are associated with it, and the systems really that are associated with it, it's really helps us to understand the building. Why is it performing this way? We can predict failures ahead of time, and we can make the building run more optimal and more efficient, which I think is a big piece. The other piece is carbon pricing escalation. Those are things that we kind of looking at that you look at this, and right now it's probably not as important since the carbon pricing almost kind of came off, right? So things are coming in and out. Measurement and verification guidelines. So that piece is specifically looking at all the sensors that we're putting in each building, right? So right now we're asking for every major piece of equipment to have its own sensors for us to know what's their usages. And it helps us to determine if the system's running optimally, in an optimal position, and also, is there something that we should change, and helps us kind of looking at in the future. Renewable energy and carbon offset programs, that's something we're looking at as well. And standard methods for modeling. So with every new build that we're doing and all that, actually we did a set of pathway studies. So at the end of the day, we're going to be owning a building energy model for every facility that we have. And why do I think it's important? It's important because then we can test new technologies, and if we want to change mechanical system on a building to see the performance of it, or increase the R value of the envelope, or change the windows, we can see how the building is going to behave and actually see how much money we're going to be able to save. So we're looking at this being a standard, but actually outcomes of the standards are actually tangible pieces that helps us manage these facilities going forward. And I'm always been a big proponent of having a digital twin. So from the start of that, the deliverable right now at the end of my project is actually a BIM model in Revit right now, to having an energy model in this as well. This really sets us up well for the future to understand the building much better in its operation, and any future addition or changes we can really try. We can model within the the virtual space and see if it's actually going to work, which I think it's important. And it's like, I'm not even saying that it's bringing us to the future, but it's almost bringing us to the present, because I'm hoping that everybody else is doing the same thing. All right, so that's maybe enough about resources, and we're adding things back and forth, and we're changing things nonstop. So what's actually changed already, we are having new security standards that we added to this. And like I said, we wanted to have a one-stop shop for all the consultants to come in. Everything's in here. Make sure the new facility is designed to these standards. As long as you do it, we're going to be happy. We're not going to have to, oh, you know, we forgot to give you a security standard and halfway through we're running into it. And then we have the administrative recommendations. So that whole piece is about Durham standard team and procurement guidelines and training process. So this is about the team that actually manages the standard itself from behind the scenes. So this is really the administrative portion of it. You know, us looking at different procurement methods as opposed to standard CCDC2 contracts. We've been actually exploring different things like, you know, we're doing one of the buildings right now in CCDC5B, which is construction manager, which is, you know, it's running pretty good. Right. You know, this is kind of looking and touching on 3P processes and various different methods of delivering projects that helps us maybe I don't know. I mean, us being risk averse, I think this helps us to kind of get us out there as a municipality and kind of consider different things. The issue with that is because a lot of times new technologies are really sorcerers in a way that there's only one company that holds the patent and they only make it. And currently it's very hard for us to make sure that we include these within our tenders and documents. So we developed this whole piece in order to help us, you know, be at the front and understand that. I think we should lead in certain ways because, you know, if we can show, you know, the private sector that this works, then it definitely is going to be a bigger piece on you know, for them to give this, yeah, let's say it works for you guys, then it should work for us as well. And then the training program. So everybody within my team, as well as consultants and everything, we do have a training program that we develop that we kind of go through. We show them how to use the standard, what is it used for, and we explain how this works, and then really, you know, make sure it's actually being adopted the way it's supposed to be adopted. All right, let's jump to the next one. Okay, so this is going to be just to go through the design checklist. It's going to show you different things. So again, there's when you look at each one of the checklists that you have, we have 3 checklists in there. So it's a master checklist for the regional internal use. So it'll be a list that was going to have you know, I don't know, like all the measures that's in there. Then what we do with that list as a region, we kind of go through that list and we get the design team checklist for consultants. So they go through the secondary checklist and they say which targets they think apply to them, or which targets they're not able to meet and why. Obviously, there are different situations, different conditions that sometimes you're not able to meet a target, or, you know, we have 3 or 4 different options for a target. For example, for roofs, we have, you know, you can have a cool roof, you can have a green roof, you can have, you know, if we do a solar roof, then there's the different configuration of things. So this essentially is being filled by them, and they can explain this to us. And then we do a review at the end if we agree with this target, or should this target, you know, with their comments and with what's being proposed or not. So, okay, let's jump to the next one. I think the next one's actually gonna, yeah. Okay, so again, this kind of has the description, what's in the supporting documents, which we already talked about. All right. Okay, same thing. So now capital project implementation, we're gonna kind of run you through how this is being applied and at every stage of the design project. So here is the request for proposal stage. So this is initial stage when you do. So our team, and this is exactly what we do. So our team, so I have a project managers on this, technicians, they look at this. We also meet with the maintenance staff at the same time. And with the client. So for example, if we're doing a project, for example, for DRT, which is Durham Regional Transit, we're going to meet with the representative from the transit, from their operation side, to understand what their needs are. And then we review the standard. We decide which of the optional design features we're going to be using. That's in our design team checklist. We kind of mark off that this is it. We attach the project specific checklist to the RFP that actually goes out to get the consultants on board. And we review the proposals to ensure that the proponents have the capability to deliver the projects, obviously. On the consulting side, they just review the RFP and they check the design checklist, and they include in the RFP documents that really demonstrate that they're able to deliver, or they have done previously delivered the work we're asking for to be delivered, right? That's how we score the RFP. Generally, they have to prove to us that they've done this work before. And sometimes they'll be telling us, you know, they'll be kind of looking at this and say, okay, we know we can solve certain problems that way. Although we don't generally expect for them to solve our problems at the RFP stage. Okay, let's go to the next one. So then we proceed to the schematic design. So schematic design, as I understand, this is once we have the consultant already on board, and they provide, again, we have a project-specific design team checklist that they review. Once they provide us the populated checklist, we review that checklist. So the design, the Durham team, they reviews that checklist for compliance with the standards. When they're not met, we may ask for additional justifications and questions. And sometimes we agree with them and sometimes we don't, right? Like my staff right now, just to let you guys know, like we are highly technical team. I have number of architects, engineers from civil, mechanical, electrical, structural on my team. So a lot of times we're going to be looking at this and we're going to know what's good, right? What's not. Is it true? Is it not true? On that aspect. Like I'm an architect. Bhavesh is a mechanical engineer. So we do have a lot of expertise in-house that we bring to the game. So when we're reviewing these, having that knowledge is great. And also I think comes from the years of experience working for the region and doing these buildings, that we actually bring a lot of experience to the table as well. So reviewing it, we know what works, what doesn't. We operate on those facilities on a daily basis. So we're building up on something that we already know works, or we're asking to change something that we know doesn't work and we know why it doesn't work. So once the design is accepted, we provide approval, and we kind of jump to the next stage, which is the detailed design. Again, on the consultant side, they have to provide us the design checklist. They have to track the compliance. They have to provide us reason why stuff doesn't meet the standard. If it's rejected, they have to revisit the design, and they can't proceed to the next stage without the approval of this. I see there's a bunch of questions in the chat. So do you want me to answer them now, or would you like to answer them at the end? I don't know. How do you guys want to do this?
I think in general, keep going with the presentation and then we'll leave some time at the end. That'd be great.
Perfect.
Thank you.
Okay. Sounds good. Thank you. All right, let's go to the next one. Okay. So, so detailed design was completed. Yeah, so we got design development. So again, just continue with the design. As you know, we have different stops and or gates during our design phases. We sometimes do 30, 60, 90, and then final set. We do 50, 100 sometimes, just depending on the projects. In essence, they have to provide at least twice. They have to provide a full design checklist, and we cannot go to tender without having a design checklist signed off by the Durham design team. And again, so it's kind of going back and forth. If we see things we don't like, they have to revise it, they have to change it until we're happy that they met the standard, or they have a really good explanation why the standard is not being met for a given measure. All right, let's jump next. So now we go into construction documentation. So actually, the Durham standard is included within standard RFP or a request for proposals for the contractors to kind of bid on. Again, and we kind of make sure that it's there, and once it's ready, and they provide, once they put their bids in, generally we use CCDC2, which is the really the lowest bid wins the contract. But having the documents and everything in there, we ensure that everything is being met and the contractor understand what they're delivering. I think that's the big piece going forward. Okay, so grab to the next one when we jump into the construction. So during construction phase, again, we do, we have commissioning agents that looked at this, make sure everything kind of aligns, and again, consultants present there doing the whole construction piece to make sure that everything that's being done on site is done as per standard, as well as their design, which is aligned with the standard. And again, if we find things during construction phase that something is not being met, things happen. That goes back to the team is being reviewed, which we're seeing options. We want to see how it's being reviewed. And we either say, yeah, okay, you're right, or we tell them, no, it can be done in a different way, or you got to come up with something else because we're not going to be allowing for this to go. And again, by the end of the construction, really, what we're looking at by 100%. So there's number of measures, and when we look at the substantial of the building, there's number of targets that has to be met above and beyond just CCDC2 requirements for that. For example, one of the big ones to me, I think, is that we require building to run for 2 weeks without any breakdowns, right? And everybody's been in my maintenance staff's been trained, and all the manuals been delivered for all the equipment coming forward, right? So those are the other two pieces that are typically not there, but they help us really understand this, because the building automation systems are intricate, and we want to make sure that everything works and it's running before we issue the substantial performance. All right. And I guess that's what I was kind of more talking about, that at different phases, right? So that's so really the substantial performance is, once we do this, we make sure everything's been met, it's been hit. Consultants actually are checking, they're going emissions, we're testing every piece. We're testing, like we're doing geothermal systems, for example, or we're doing the solar systems. We make sure that the targets are being met, everything works in conjunction with the BAS. We're able to monitor things, and the building's actually performing to the way they're supposed to be performing. What are we doing then? It's the next step, which is post occupancy. So for the period of over 1 year, we do have a commissioning agent that works with us to ensure that the building is actually hitting the performance targets. Like, I'm being realistic. We know that the building from the get-go is not going to be running the way it's supposed to be running. It's going to take us roughly a year to understand the whole cycle of the building and to adjust the BAS in order for us to be the most optimal and hit the targets that are required. So that gives us that 1 year post-occupancy in order to provide, to make sure that everything runs the way it is. And then we can see the full cycle, summer, winter. Are all the system running the way it's supposed to be running? Are we good with that? And if they are, then great. Then we can kind of sign off on it and we move on. All right, next. And then there's just administrative implementation on this. So we're going to talk about the training, a little bit organization of the standard team, and complete task directed by the team. So let's jump into this. All right, the development process. So this kind of gives you a quick outline. So we actually started this in July of 2019 to March. We have phase 1. So we revised with the help of a consultant. We actually engaged Purpose Built building at the time, which is a company that actually helped City of Toronto to develop their green standard as well. So Purpose Building on this end, we review and summarize the regional existing standard processes used to deliver capital projects. So that was quite a large undertaking to look at all our different standards that are located in different areas, and then look at all the targets and really inspiration that Region had, and kind of develop a framework of what our target is going to be. The second phase of that, which kind of started at the same time, was to compile a list of other industry standards, municipal standards, that we're going to consider during the development of our standards. And so that kind of took some time as well. And then we jumped into phase 3, which is development of actual the drivers for our standards, development of the draft, revise the draft, review it with the whole team, which is going to we're going to share with you guys right in the next slide, I think, and then finalize the standard approval for adoption. So at the end of this whole process, once we standardize, we went back to our council, so regional council, with a report to approve the standard as our standard for the buildings, and they did so. So right now it's all official. Everything has to be following as per council recommendation. Okay, let's jump into the next one. All right. So this kind of showed you the different phases and again practices, and this is more like a graphical representation exactly of what happened, and then how it's developed and reviewed. So very, very quick one. I think we already went through this one when we talked about this. So let's jump to the next one. All right. So when you look at the team that was kind of working on developing a standard, you would have, as you can see, it's a very broad spectrum. So we had a design, construction, asset management team on our end. We had purchasing. We had asset management that looks after, all of the region and different targets for the region itself. We had facility maintenance and operation division. Again, that's the guys that actually maintain this. We have finance on its own. So that's the guys that actually give us the money to run the projects. We do have accessibility committee that actually looks after accessibility. Again, we do have also a diversity, equity, and inclusion committee, as well as climate change committee. So those groups are very important, and some of the targets are specifically driven to the different goals that they may have. Okay, we can jump to the next target. All right, and actually that's about it, what we have. So we can kind of jump in and start answering some of the questions for you guys.
Thank you so much. If anyone has any questions, feel free to just unmute and ask them. No need to raise your hand. But if you want to as well, you can also type them in the chat and we will monitor that as well.
Yes. Hi, I have a quick question that I would like to ask. In these projects that your company is focusing on, is it required for them to use any software, specific design modeling softwares, such as AutoCAD and Revit, when it comes to pretty much before creating the project, they model the project first, they analyze it in the software to see if it meets the standards of the Durham or the building code standard?
Okay, that's a good question. So actually what we have, our standard for delivery of the projects, actually, we're using Revit. So we need a BIM modeling is essentially coming into play. So yeah, it's Autodesk product. We moved away from CAD drawings just because we want to go to 3D. So the model has to be prepared in Revit, and we do Revit checks. We do have a quite detailed deliverable list and LLD, so level of detail requirements for each one of the stages of the project. But yeah, so we currently are using Revit. And for energy modeling, I think Bhavesh can jump into that one and tell you what energy modeling software we currently are requesting for the consultants to provide.
Yeah,
Okay.
sure. So
Sorry, was I interrupting you? Because the reason why I've asked this question is because I'm completing the building information modeling management at the George Brown College, and I have experience in using Revit as well as AutoCAD. And so I am very good in hands with modeling 3D buildings as well as conducting an energy analysis on these buildings on the IES. So one of my projects that I was working on was a residential building and a commercial building. So with the commercial buildings, I was able to do the 3D modeling in the AutoCAD. And as with the residential, I used Revit for it. But when I went to the BIM, I recognized that with the Revit, we can transfer it to the IES. And then we can conduct an energy modeling analysis to see how much energy is being used in this building.
Yes,
So
yeah, exactly. Well, that's the whole idea behind having a digital twin. Again, there's various tools on the market right now that you can use, right? When you look at even doing a BIM. I mean, for us, the reason why we're using Revit is just because it's a standard that's adopted throughout North America. Like when you go to Europe, it's a little bit different, right? They use like ArchiCAD and various, or you get like a Bentley, very different models. But like I think what you're using is pretty much industry standards right now. Bhavesh, what are we using for energy modeling? We're not using IES. We're using something else. What are we using?
Yes, so we are using on a software from DOE, Department of Energy. Previously, we were using eQuest, but eQuest, these days is sort of rudimentary. We are not getting regular updates on the software itself. So we are slowly transitioning to Energy Plus. That's also an offering from DOE, Department of Energy, and we are using various GUI. So that's graphic user interface. So we have options like Open Studio, we have like Design Builder, and some consultants have their own. They call it in-house or house-grown software. So that they basically use them as a GUI to Energy Plus.
Right,
And
right. So yep.
sorry about that. And just wondering, what's the next project that your company is going to focus on building? The new project, if it's all right if I ask this question.
At the region, so we're a municipality, right? So we're government. So we do a number of projects, right? So it just depends what the council is going to approve next, right? So we have budget approval in December, and depending what they're going to approve, that's the next piece we're going to be building. We do have a number of projects that are on the go. I can't really talk about those just because if people are bidding on these, we don't want to share any information, and that would preclude them from bidding on these. But there's a number of projects that we're doing. Yep.
I see.
Yeah.
So yeah, the reason why I asked this question is because I'm into modeling, too much of the modeling, and I'm hands-on with the modeling. And so I don't, if you guys are looking for someone to model anything, I don't mind doing it. That's why
Yeah.
I'm saying this respectfully.
Okay. Awesome. No, so just generally we hire consultants that do this work for us. As a government, we generally don't do that work in-house. We review their work, but we don't because they have to take responsibility for the designs themselves. But yeah. Okay. Yeah, if you want to, shoot me a quick email. I'm sure there's a few firms I can point you towards to. If you want to like reach out to them, it would not be a problem.
Is it all right if I can receive your email by any chance?
Yeah,
it's part of the presentation.
just to be aware that, we've got 46 people on the call. And so I know we just have a few cameras on, but all of the students, of course, are eager to get jobs, links and what have you. But specifically, I think this is really exciting. Here we have a municipality, so a city government or a regional government that you're the city of Durham, or is it the region of Durham?
The region. We're the region of Durham.
So the region of Durham has this new standard. It has been approved. It is a brand new standard. It was really interesting for me to see this development of how you looked at all the other standards that are out there and you've created your own. And it's, as Sustainable Buildings Canada, it's an amazing standard. I'm curious how much pushback you might be getting from the building community about having to meet these excellent standards.
That is a good question. That's a good question. So for me, it's a little bit different just because this is our corporate standard. So like when you go to get a building permit for your own project, you generally run through a lower tier municipality. So it'll be like a city or a township, right? That you run through. Now for us, it's a little bit different. So it's almost like this is our corporate standard. So every building that we build for ourselves, we have to follow the standards. Now, but like as you know, right now there's a big pushback on what the provincial government right now says about the green standards and do they stand or not stand, and especially right now, is the Toronto green standard applicable or not applicable, right? That's that we'll see what that's gonna end up. I mean, it's probably with some lawyers and not with us. Now our standard is separate. It's gonna stand because until the council decides that we're not gonna follow it, right? So it's like in essence, like our board of directors told us this is what you guys gonna hit, and that's what we're gonna be hitting, because this is the other targets that we need to do anyway, right? So I don't see the standard being removed at any time. Maybe a portion of it because the targets changed, but it just updates, right? When I look at it that way, it's just updates on this end. But I think we'll see what's gonna come out, right? It's a big shift right now. I think when you look at Durham standard, it's more than just the green standard like people think, right? We have that accessibility, space planning. We do have resilience, which is a big piece, which people don't understand really. Like, the buildings have to be resilient, right? We got these blackouts coming up. Like I can't see that EMS station suddenly is gonna be have no power and we can get ambulances out, right? Or police stations, right? That would be just a nightmare, right? Or our transit buses are basically designed to be shelters during emergencies, right? And if we're switching to electric buses, that's another piece that I need to make sure the facility is able to charge them during those emergencies, and then we can provide this. So a lot of moving pieces. Okay, I can take some maybe other questions, or we got questions I think in the chat. Asking, does each province have their own standard? I think if you're referring to like a building code, I would say yes. Obviously, Ontario has its own Ontario building code. Each one of the provinces will be a little bit different. We do have a national building code that kind of is overarching. Some provinces adopt it a certain way and build on top of it. But generally, yes, every province would have their own standard coming forward. I think maybe that was somewhat answered. Are municipalities saying a higher standards? I would say yes. The reason why we're saying a higher standard is because we do have different goals and different targets and different, when we look at our inclusivity, right? We, for example, are implementing number of gender neutral washrooms, right? To ensure that's something that's in a building, and it's not in a building code, right? When we do our front counters and all accessibility spaces, we go on above and beyond building code that still gives you a loop ways that, if you can prove it that the person that that has some accessibility issues are, not going to be working here, then you don't have to comply to this, right? We don't do that. We make sure that we're able to provide access everywhere. And I think that those are the big pieces, right? We are above and beyond the typical building code. I mean, think about that. Building code is really the minimum that you hit. As much as I hate Mike Holmes, I think I can kind of quote him here that the building code is really the minimum you need to hit, right? It's the lowest bottom level. So don't tell me you build up to the building code, you build down to the building code. You can't build any lower than this, right? So maybe that's kind of cool. International standards. Yeah, international standards are cool. I had this question that came to me a few times. Now, the big issue with international standards, they're not really specific to where we live. And the climatic data and the usage specific for here are very unique. And that's why we have different one in provinces. And even if you go to the building codes, like snow data and rain data, it's like so area dependent, right? I was, in my previous life as an designing buildings, we moved, I think, outside of Orangeville, and it had the snow load was double than what's inside. And then we're like, okay, we did, and it wasn't really, and it's like, oh, really? Wow, that's huge, right? So, yeah, international codes are somewhat okay, but you still have to, your building still has to be built to the local codes, and that's why a lot of times what you see when you have big firms that are great, international firms, they would partner up with the local partner in order for them to, to make sure the design's locally approved. That's one, and it really follows the codes because building code is quite in depth, right? You need to understand all the loopholes and all the requirements and how you apply it, really, and that's the big piece of that. Yeah. Prescriptive design, building code performance. Okay, that's a good question. I don't know if I want to touch that one. That's very yes, there is prescriptive design method. There's caveats associated with that. We went through that with approving our process a few times. Generally, it's very lengthy. If you're designing something, it's better to just follow the standards as opposed to trying. Perspective design is really there if you're doing something that doesn't fit for certain specific reason, right? If you have the time and money to use it for, and you really follow the design, then yes, but be prepared that the local municipality may say no to you, right? It's not something that if you're doing a perceptive design, it's not that it's a given that you're going to get it. Now, on the other hand, if you just follow the building code, or in our case, our standard, if you meet it, you meet it, right? You don't have to worry about that piece. Yeah, okay. Do I find that I'm getting less bids from the bidders because of the design standards? I would say no. For them, the job is a job. We had this worry initially when we started doing a lot of projects in Revit that we're going to have an issue with that, and we don't. The industry is adapting. For them, it's money, right? It's a project is a project. They don't care if they do, really a gas fire unit or air source heat pumps or geothermal. For them, at the end of the day, it's money they're making on top of it. So I don't find it. And actually, lately we've been getting more and more bids. So industry definitely turning, and they understand where this is going. All right. Cool.
Yeah, Jack, there was some interesting discussion on passive house.
Okay.
And we know there's
Sure.
one of
You
the
want to touch that one?
pathway path. Yeah. So yeah, passive house is originated from Germany, but yeah, we have adapted it very nicely. And yeah, interesting enough, we have 4 compliance path in one of the requirements under sustainability and resilience checklist, and one path is being passive house. So once a building is certified for passive house, we approve that this compliance has been met just by having that certification from passive house.
Nice.
Yeah, and actually to kind of maybe say a little bit of history too. I think when you look at the original passive house, the homes or the buildings were actually designed in Alberta. I think the first ones, when you look at, they're local to Canada. They're not really German. Germany kind of took what we did and made a standard out of it in essence. But yeah, having built initial buildings, when you look at the crazy amount of insulation and really good windows and the percentages between glazing and the walls, it's really some of that stuff's coming from from us, which we should be proud of. All right.
I got a question. So like right now, there's a big push to like build more houses, especially like for like governments and municipalities. Like it's talked a lot about in the political climate how much of a housing crisis we have. So do you think the standardization of building and putting such an emphasis on high performance building makes it harder to achieve this goal to create more houses?
Good question. Good question. I'm going to tell you there's few ways to approach this. I mean, making buildings more efficient does not make them. It doesn't have to be more money. Like when we look at their numbers, to hit the targets is generally 4 to 5% more currently on the building, overall building cost. Now there's different ways of doing this, and you can still hit this. Like we've done a number of buildings. They're modular, which is kind of interesting. Like one of the buildings that we've done in Beaverton actually received a bunch of architectural awards, and it's super efficient, right? So I think when you look at that you build buildings that are more efficient, it's actually good for you because they're going to last longer. Generally, you use better materials. That envelope actually is designed to perform the way it's supposed to perform, and doesn't really mean that it's more money. You can do it in a way that it's not going to cost that much more, and you're still going to hit the targets. And other piece of this is you really have to look at the infrastructure. The more we build, the more infrastructure, especially our electrical grid, it gets taxed. So we have to be mindful of that. And when we're building new buildings, we have to make them as efficient as possible. And this way we can, essentially instead of one building, maybe we can put two buildings that are going to have the same energy use. And then the grid doesn't have to be expanded so much, right? And then we don't have to build so many new nuclear power stations or other sources. Does that answer your question, I guess?
Yeah. Can you clarify? You said
Sorry,
that a high performance building is only 4 or 5% more expensive than I guess a traditional building that's not trying to achieve high performance.
This is kind of what we found, not on the high performance. When we look at the buildings have to follow some of our standards and go into be a GHG emission free buildings, right? The cost of this roughly we found on a project wise, and don't quote me 100% on this, but I've seen some numbers coming in actually from the region of Peel, I believe. And when they looked at their projects, again, it's too early for us because we're still looking at this, and COVID really threw a monkey wrench into everything, pricing wise. But then when they look initially at this, they thought it was about anywhere between 3 to 11% more, and that included all the retrofits, right? So if we look at just building a new building, you're probably hovering within that 6, depending on the technology you're using, you probably are hovering around that additional 7%, 6 to 7% more to make the building more efficient, right? Because you already have all these other components, so you're just increasing certain things, right? You go to like either triple pane, or you just the glass area, or you just add more insulation, right? For making the initial envelope more efficient. And then the systems are systems, right? So actually by reducing the envelope, the systems are less, right? So you don't need as many BTUs, for example, to heat and cool the building, right? So that's another piece.
Okay, interesting.
Yes, I had a question. Sorry about that. Just I would like to check. So in the region of Durham, so besides the building code and the international code, what other additional codes does your company use?
And again, I think maybe so it's like a bit like we are being municipality, right? So in Ontario, as you are in Ontario, you have to follow Ontario building code, right? That's the minimum that you have to hit. Now, for any project that we're doing on top of that, you have to follow the Durham standard, as well as and there's certain things that are specific to each given project. Because sometimes you have funding coming up from a different source, maybe there are higher targets or a little bit different things that we have to adhere to. But generally, those are the two codes you'll be looking at. I mean, anything in Ontario, you're gonna have to meet Ontario building code to begin with. So that's the one I would definitely focus on.
Okay, so we're at the end of this session. Thank you so much, Jacek and Bhavesh. That was extraordinary to hear about your building code for your particular municipal buildings. And let's hope that that transfers to your region of Durham for all buildings at some point in some way, shape, or form, and that you have excellent luck. But it does put a burden on people like Meaghan's team, not a burden that is a bad burden, but there's, Farouk is telling us how he's had to go to building code and look at those requirements, and this is a whole other level of that. But I think having that clarity is what makes it possible to do. And it sounds like you guys are getting RFPs quoted, so that's extremely exciting, and we look forward to seeing how that goes for you. We'll be watching.
Thank you very much.
Okay.
All right.
Thank you so much.
And thank you for having
Thank
us.
you.
Thank you.
Okay.
Thank you for the presentation.
Yeah,
Thank you.
yeah.